Okay, I'm back, guys. It's the next day. I've actually tried a few things off camera here, and I'm glad I did because I would have probably just wasted your time on this. But I've got a new thing that I want to try, and that's why I wanted to show you this, because this can be really cool for you to do if you're getting into amps and you want to do some modifications, or you want to build amps, you want to try different things in your circuits. This can be a really effective, cool way to do it. Let me explain what I did off camera. So I I basically checked the bias. That's one thing, which I'm not going to include in this video to show you exactly how I checked the bias, because I did a really in-depth video just a couple of weeks ago on the Gibson Skylark. I'll probably put the link to that in the description of this, and you can skip right ahead to the biasing stuff because I have the video divided up into chapters. Okay, that shows you exactly how to do a cathode bias, an amp that's cathode bias. That's what this one is. It's basically the power tube. There's this one resistor here which is setting the bias for this power tube. It's a 150 ohm resistor, and you can go to a calculator online, and I show you in that video with the Skylark exactly where to go, what the website is. You can just look up bias, cathode bias calculator. You input some information. You got to get the plate voltage, the voltage on the resistor here, which right now is at 6 volts, and the plate voltage is around, I think, 250 or 260, something like that. And then it does a little calculation based on what the tube type is and what the value of this resistor is, and it tells you what the bias rating is. Okay, and then it'll give you some suggestions. You can play with the value of this resistor to make the bias hotter or colder. But this bias with this resistor is right around, I think, 90% dissipation, which it's totally safe in a Class A amp like this with one single power tube to go up to 100%. So 90 is perfect. I don't want to overdo it. Somebody's wall voltages might be higher than mine, so I want to give that 10% a little bit of breathing room. But in this type of an amp, in this type of bias circuit, that's perfectly normal. And I don't think that this little bit of a fartiness sound that I was describing is due to the bias at all. So then I tried putting in some tubes, some different tubes, and I didn't do all of them, but I did try a different 12AX7 in the first gain stage, right? The first input, because that's your preamp section. Basically, these two triodes in a single tube, no difference there. So I put a brand new JJ tube in there. I don't hear any difference. So it's not that that's making that sound. And also I put a different power tube in there, this EL84, which is also brand new. No difference in sound there. Okay. So I've eliminated some of that. And I think what's happening is when I've worked on these in the past, I don't believe I ever hook them up to what I'm doing now to get the sound, right? I was using the speaker, the internal speaker only, I think. And I think that the way this amp is designed and with that speaker, it sounds great. The breakup sounds great. And that's something I haven't shown here yet, cranking the amp. But when I have it and I'm recording with it, which I would like to do with an amp like this, I'd like to put some output jacks on this as an extra feature so that I could use it in a recording situation where either I want to connect the internal speaker and use that, or just go direct out to a computer interface and or another speaker cab. Any kind of combination with an output jack is possible. Then I want it to sound good as well. So I'm thinking now that we've done all the filter cap changes and the maintenance on this, now I should start thinking about what sort of not modifications, but enhancements I want to add. And everything I want to do here is I want to keep the circuit original. I want you to be able to play it original. We have the history of Gibson here, how they made it in 1966. I don't want to alter that. I can make it sound better, yes. I can change a few values and make it sound better. But I still want it to be able to play it stock too, right? I don't want to mess with the originality. I don't like to do that with vintage amps. I know this isn't necessarily like a holy grail type of an amp or anything. It's not like a super rare, first run Fender amp, that's going to cost me $6,000. No, this amp is probably worth a few $100s on the marketplace. 300 or 400, maybe a little more, depending on if it's serviced or not. And all that kind of stuff. But anyway, and the condition it's in and everything. So what I'd like to do is something similar to what I did with the Skylark. I'd like to be able to teach in this video how we can add some enhancements, some extra functionality, but not mess up the originality. So I've been thinking about what I want to do here. One is I would like to improve that breakup sound, and I think I can do that. And I have a way we can kind of play with that and see, and maybe what I can do is put it on a switch so that I could say, hey, in this setting, this is stock, right? This is exactly the way the amp was designed. But if you want to flip a switch, change a setting, now it can sound like improved when it has this breakup sound. So I think that what we're hearing is just the way it sounds with the breakup, which to me, like I said, when I describe it as farty, it's a little like kind of overdriven and blocky sounding. It doesn't sound smooth. It doesn't sound to me like I thought it was going to sound. Now maybe when I connect the real speaker, it does sound great. It probably does, because I've worked on these before and I played them through the original speakers and I never thought they sounded bad at all. I thought the breakup sounded really cool. It was really overdriven and wild, and if you hooked this, a microphone up to that speaker, you could record some pretty cool kind of rock sounds. But I don't think it sounds great going in through my computer using virtual cabinets with the way it's designed, and I think I can improve that. So that's what I wanted to do here, and show you how you can play with it so that we can come up with a different configuration for how the gain structure is designed in this amp, and use these decade box capacitance boxes to replace resistors and capacitors in a certain area of the preamp to alter that gain sound. And when we come up with the right configuration, we could say, okay, this combination of resistor and capacitor sounds really good on the enhanced one, and then here's the combination of resistor that is in the amp, so let's switch it to one or the other, right? Like, let's have a stock setting and let's have an enhanced setting, or whatever we want to call it, right? So that's one modification. Another modification is maybe possibly adding a depth control. Now, I've been listening to this tremolo circuit, and I don't think the depth is quite as intense on this amp as it was on the Skylark that I just refurbished. The Skylark has tremolo, and it has the same type of a very similar type of circuit, but the intensity part of it is like 100% stock, right? Like, it's when the waveform kind of comes in, you hear your guitar, and when it oscillates and goes out, it's 100% out. You don't hear any signal at all. So if the effect is going wow, 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 like that, when it gets to the bottom part of the trough, you don't hear guitar at all. So for me, it's not very musical. I like to still hear a little bit of my note ringing out underneath while you're hearing the tremolo. And this kind of does that. So I don't really think it necessarily needs an intensity control, but maybe it'd be nice to control that, right? Maybe I just want to hear it slightly, and the song that I'm writing just needs a little bit of effect on it, but not a lot. So that would allow me to do that. And it's a pretty easy mod. We can add a pot in there, we can adjust it. So I may do that too. All right, so possible enhancements to the voicing and or gain structure, or at least a setting that I could choose to use or not use. Being able to control the intensity of the tremolo effect. It already has a speed control, so we're fine there. And it has an on and off, so we don't need that. It would be nice to control that level. So that's another enhancement. And there's a lot of other things we could possibly do, but I want to kind of start there and sort of see what else might be good for this. Because maybe once we get into the gain thing, we might say, hey, you know what? It might be nice to do the tone a little different, right? It does have a tone knob. That's good. We're going to leave that stock, but maybe have a switching option to say, why don't we use this tone structure instead? But I'm going to see how the gain thing turns out first. All right, so let's get started on this. What can we do to play with this to come up with a better sound? Okay, I'm going to disconnect this speaker here, or output jack cable here, just for a second, just so we don't have so many cables here. Well, actually, you know what? I will need that soon, so I'll reconnect it when we're ready. So what I'm doing here is I want to show you something real quick. In a guitar amp, in the preamp stages, I should say, because it could have multiple stages. If anybody wants a copy of this, you can send me a message on YouTube or wherever you're watching this, and I'll email you a copy or share a copy with you through Google Drive or something. I downloaded this off the internet, this schematic. There is a printed schematic inside of the cabinet, which I think some changes have been done. Like this 15 picofarad cap is not on that schematic. Let me show you what I'm talking about. I'm going to see if you can see this. See that right there, that paper? I'm going to maybe try to take a good high-resolution photo of that because I can't really find that online. And maybe I'll have that as well that'll be shareable in case you need the actual real schematic. This is very similar, but for some reason there's a couple of slight differences. So, I want to make it original to the one that's printed on the inside of the cabinet because I believe that does match up with the one that I drew from real life from a Kalamazoo 2 amp that was never touched. I drew this myself and it had every single part, what the value was, and how it was actually wired in here. And I believe this does match that schematic that's on the inside of that cabinet. But this is a lot easier to read schematic wise, so I'm going to just refer to this for a second. Interestingly, oh man. Yeah, see, this is drawn differently. I thought I was going to be able to use this, but I don't think I can. What I wanted to show you was, okay, here's the first gain stage. And don't worry about if you can't see all the detail. I know I'm just showing this to you on paper, but it's okay. I'm just going to point to some things and talk about it. So this is one half of the 12AX7, right? There's the plate here that has the high voltage on it. Here's the input jack, and your signal is going into the grid of the tube to be amplified. And then this is the cathode. Now, depending on the amount of voltage that's here, that's going to kind of give the gain character of that stage, a specific kind of a character. I don't want to change and mess with these voltages because they're coming from the power supply. They're coming from these filter caps and all that kind of stuff. I'm going to leave that alone. But one thing we can change very easily, which will give a lot of character and tone and break up conditions, I should say, in these stages, is this cathode right here and what's on that. So currently, for the first gain stage, there's only a 4.7K resistor. Sometimes you'll see in the first gain stage the resistor and another capacitor together, right? If we go to this second half, you'll see that for this cathode, it's coming down here, and here's your resistor and your capacitor. It's that 10 UF cap with a 4.7K resistor. That's being shared with the next stage of the other part of the the tremolo oscillator circuit. That cathode is being, this resistor and this cap is being shared by that. So interestingly, it's almost like, well, I know that 10 UF Fender in a lot of their older amps used in like in the first or second gain stage, they'll use a high value cap on the cathode. So they'll use like a 22 microfarad or a 25 microfarad, or sometimes even maybe a 10. But that's a very high value. Sometimes people don't put a cap at all, or they'll put like a very low value capacitor, like a 0.1 or a 0.022 or a 0.01 cap, something like that, with a resistor of a different value, and it will give that tube different characteristics, right? So what I would like to try is, one, I'll leave this resistor in place for now, but I'm going to see if we can separate this connection here so that we have a separate cathode that we can put our own resistor and capacitor on to see if we can modify the sound of this amp just by changing it here. So you see what I mean by this is shared? This cathode is connected to this cathode, and they're both sharing this same cap and resistor. That's the one cap we replaced. That's why it's small, because it has a very low voltage. So if I can separate this and leave this on the tremolo circuit, just let the tremolo circuit do its own thing, maybe I can get a different kind of a tone and breakup in this preamp stage. And they probably did this because it saves money and, you know, whatever, but I can tell that this value 10 here on this stage is probably going to create that farty sound, because it's such a high value capacitor in this spot. So when you go to push the amp and have the breakup, it's going to have a lot of bass frequencies, a lot of low end, and we can kind of cut down on that and see if we can get that breakup to sound a little smoother by changing that value. But first we have to separate them. So again, I want to be able to keep the amp stock, but I'm going to separate them for now to play with it, and when we come up with something that sounds good, then we can just put this on a switch and say, switch it so that you're sharing it, or switch it over to this other thing. Okay, so that's why I'm gonna disconnect it for now so we can play with it, and then maybe put it on a switchable type of a thing, right? So we're not messing with the originality, but we can switch it to an alternate gain stage setting, so to speak, to hopefully make it sound better. Are we going to be successful? I don't know. That's why we're going to try this, okay? So let's I wanted to explain what I have here. I've shown these in some other videos, but these are basically tools that I can use to put a resistor in circuit while the amp is live, while it's on, and change that value while it's live without unsoldering things. So this is called a decade box, and it has just about every possible value up to maybe like 10 megs, right? So you have 1M here. If you turn on 2M and 1M, now you have 3M, right? And so on. Or I could say I'm going to use a 100K resistor, or I want a 110K resistor. Switch these two on. So it's a really cool thing where you can switch these while the amp's on and play your guitar and listen to the sound change, right? As long as you're careful with the values and you know what you're doing, so to speak. You don't want to, you know, if there's a spot that really needs, like this bias resistor, if you're changing that bias resistor, you're going to be changing the bias on the fly if you're using a box like this with that. And also, you have to keep in mind that these decade boxes, they're not designed for changing and swapping out resistors that need to be a very high wattage value. Like this resistor here is like a 3 watt because it's very, very big. It needs to be larger to handle more heat, to handle more energy than these smaller guys, right? But if you have a 1 watt or a half watt resistor, you can totally use this box in its place and play with the values. So this is a very handy tool. I don't remember where I bought this. I bought it probably at least a decade ago, probably Amazon or some electronics supplier. This one though I got from either eBay or from like a Facebook market thing where they had a bunch of old tubes and some equipment. But this is an ICO made one. This is a capacitance box. So this is basically like putting a capacitor in circuit and out of circuit and changing its value on the fly. So I want to use these two to replace this shared 10 UF cap with the 4.7K resistor and change the values until I get a sound that I really like. So having these boxes is great because I don't have to keep soldering and unsoldering, trying a different value. That takes time. That's you know, crazy, you know. Now it would be cool if I could have multiple boxes and say, okay, I'm going to put these two boxes on this stage and then get another set of boxes and put them on another stage so that I could have multiple stages going at one time. But that's, you know, I don't have that many of these kind of tools around to do that. If I was designing a circuit, that would make it go faster, but maybe I play with one stage and get it to where I like it, then switch over to another stage if I'm going to do it that way. But in this case, I don't like the fact that this is shared and that this is such a high capacitor for this stage. I think the breakup will sound a lot better if we can separate it and give this cathode its own cap and resistor value. And again, put it on a switch so that we can make it switchable. So let's connect. Let's connect or get these ready for connecting, basically. And the area that we're going to be swapping these things out is not high voltage. This is very low voltage. This is relatively safe to do as long as you're very careful about these alligator clips and not touching something that, like if you're putting it on a specific pin, make sure it doesn't, you can't lean over and touch another pin because you could create a short, right? You know, or put high voltage on something that's not supposed to have it. So you do have to be very careful of that. But as far as the voltage that's supposed to be going to these things, it's going to be a very low amount for the working with these cathodes, okay, of the tubes. But we can change those values and really give the amp a lot of different character. So let's try this. I'm going to get this hooked up. First thing I need to do is disconnect the cathode from the shared part, and that's really just this little yellow wire right here. This yellow wire is going from the cathode of V1 of that second gain stage, and it's being shared here with the cathode over here. I still want to keep this in circuit here and not remove these because that's part of the tremolo, right? That's what's making the tremolo part of what's making it work. So I'm going to leave that there, but I don't want to use it on here. I want to replace that value with these two boxes. So let's just remove this wire from here. Let me grab my iron. I just have to take a second to get it hot. Actually, while that's heating up, I'm gonna go ahead and reconnect my speaker speaker cable so that it's ready when we're ready to turn this on. We're gonna have a lot of wires going a lot of different places with this, but again, it's nothing dangerous. I'm not pulling high voltage out of the amp, as long as I'm careful and I know what I'm doing. Alright, so all we have to do here is take this yellow wire, although you know what, it's going to probably be wrapped around here a couple of times just based on the way they did this, so it might take a little effort to get it unwrapped from this terminal. Sometimes if you have trouble getting that solder heated up, it's taking a little bit of effort here. If you add a little bit of new solder to it, it'll help it flow faster. There we go. Okay. I may need to actually cut this because I don't want to break anything. Yeah, see, they wrapped this around multiple times. I'm going to go ahead and just clip it. I'm afraid I'm going to break this pin of this socket if I try to wiggle that too much, but I'm disconnecting that, so there's nothing on the cathode of V1 right now. I can leave this wire here and it's not going to hurt anything. I'll leave it connected to that tube socket, but see, typically this wire could go to a switch now, and I could switch it and say switch it to go here or switch it to go somewhere else where we can put a resistor and a cap. So let's do that. Let's connect a resistor and a cap. And we'll start. Oh, I can't start with the original value. Oh, yes, I can. I guess I could, because this box only goes up. This capacitance box doesn't go up to 10 UF, which is the current value of what this is connected to. This only goes up to like 0.1, I think. I think it only goes up to 0.1 UF. So, and this is 10 UF. So it's not even 1 UF. So if I want to put anything between 1 and 10, I'll need to actually clip in an actual capacitor. But we'll try it with this first, right? Let's try it with 0.1, and the resistor value, I'll just keep it the same as what this was, which is like a 4.7K, right? So we got 4K here, and 7 would be 700, so that's 400 plus 300, so that's 4.7K. And if you're not sure and you have one of these guys, the LCR tester. Remember, this is different from a regular multimeter. We can put this on 200K and make sure that what we have set over here on the box is what we're getting. So I can connect these two leads now from the decade box, right, to here, 4.7. See that? If I add 2K to it, now it becomes 6.7, right? So yeah, I'll keep it 4.7. Hold on a second. Make sure this is all connected. Yeah, 4.7. Okay, see that? So that's just proving that we're on the right setting, and that's the current resistor value. So all we need to do is connect the one end of this cap, and this resistor is just going to ground. So we have a ground over here. I'm just going to use that same ground. So one end needs to go to here. Well, we could actually use this yellow wire, believe it or not, because that's where this thing is connected, and the other end of the resistor needs to go to ground. So I'll just connect it to this ground tab, and just make sure that these are not touching anything else except what they're supposed to be touching. So that's the resistor in place. Now we have to put the cap in place, and again, I can't start with 10 UF with this box, but I'll start with the highest value it can do, which is at 0.1, and we'll see if the gain sounds any better at that setting. And then we'll play with the the resistor values and everything. So I can just connect let's see if I can connect both of these. So that's like me connecting it to that pin, and then I just have to go to ground over here. So it's just going through a capacitor. Now this box here is not capacitors that are polarized like this one is. This one has a positive end and a negative end going to ground, right? But these aren't polarized caps. Until you get up into like the 1 UF range, they're not going to be polarized. So it doesn't matter which end you connect to which. It just needs to go through that resistor to ground, through that capacitor to ground. Okay? So at this step, we can try the amp and see if it sounds any better. All right. I have the amp turned on now. Sorry, hold on. Trying to set my headphone volume level. The amp's on, and I can already tell, I think at this setting it probably sounds better. So just listen to the gain as I turn the volume up. Volume's all the way up. Maybe still not great, but let's go ahead and connect the original capacitor back. So all I really need to do here would be, let me think of the easiest, fastest way. That's going, black's going to ground, green's going to ground, this and this. All I need to do is connect that back to there. So if I take these off, here, I'm just going to use this red one to reconnect the original. Here, back to this. Okay, let me switch it back now to the new setting. So it's the same resistor value, but it's a 0.01 cap instead of... Sorry, I have to make sure that I get this in here. It's not much of a yellow wire. I should probably strip this wire a little bit more. Come on. Sorry guys. Let me do it this way. Let me see if I can't have that alligator clip there and then just put this around the whole thing. There we go. Let's listen to this one. 0.01 versus a 10 UF. Yeah, already sounds better. Now let me play with the resistor value and change it from 4.7K to a different value, and so let's see what the effect that has on the sound. And again, the amp's all the way up, so I'm really just trying to work with the gain structure a little bit. Let's cut it in half, put it on 2K. That was 2.7K. Back to 4K. So we're getting more gain with a lower resistor. Very common value would be 1.5K in this spot. So let's do 1 plus 400 and 100 is 1.5. So we got more gain, and it doesn't sound quite as flubby as with the 10 UF. Let me play with the resistance values a little bit. Okay, I'm getting a lot of differences, but nothing that I'm totally settled on. I may want to try a 1 UF cap and play with the resistor value, because that is a kind of a hot rodded sort of a value that is used in a lot of early preamp stages for breakup for like Soldano amps, some Marshall amps, or like a 0.68, a very high value. I can't get that high here on this capacitance box. But I feel like somewhere in between that 10 and I mean, it definitely got some pretty decent sounds, and I can still play with the resistor value to sort of even it out. And again, this is only one stage. there's multiple stages here. Well, there's at least a two. We haven't done anything with the first gain stage, and I think that one would really actually set this up a little better. So we may be able to make like a multi-pole switch where we say leave the resistor in for the first stage and leave this cap and resistor in for the second stage. Put those on a switch and then use this other combination for both stages, right? And that may be the best way to make this amp sound the way we want it to sound when we're really using it for high breakup stuff. Let me just play with this just a little bit more, and then maybe I'll throw in a 1 UF resistor or capacitor just to see what that sounds like. Now, one thing to keep in mind is once we get a really good breakup sound, we have to listen to it in a cleaner, non-broken up sound, because we might lose a little bass and possibly some other frequencies by changing these values. Okay, so if you really like the clean sound the way it is, you know, that's why we're going to put it on a switch. We're going to have a stock switch. But maybe when you want to do overdriven stuff, you switch it over to this other setting. So we'll just want to listen to what it sounds like. Okay, that sounds pretty darn good. So where are we at? I noticed a big difference in that flubbiness going away. So we're at 2K plus 400, 5. That's like 2.5. So a typical resistor value isn't usually 2.5K, but there is a 2.7K. Let's listen to it with 4, 5, 6, 2.7. K sounds pretty good. Let me try 1.8 because that's a pretty common value resistor. 1.8K. That sounds great. Well, better than it did, right? Hold on. So that sounds too flubby again. Let me do this. Let me try that 1.8K resistor with a 1 UF cap. I just need to grab one. Oh, and also another one that Marshall uses is a 0.68. I might actually have one of those out. Is that one? Yeah, here it is. So it'll say 684K, 684K. That's a 68 or a 0.68 cap. Marshall uses that in the first gain stage, I believe, of JCM 800, first or second. I don't know what the resistor value is, but hold on a second. Let me try a 1 UF. This should be a 1, I think. Okay, so how do we put this in place in circuit while we're working on it? Easy. We just, instead of going to the box, Oh, but we do have polarity to worry about now because this is a polarized cap. So the positive end, we want the positive end to the cathode, the pin, and then we want the negative end to ground. So the green here is going to ground. The positive end is going to the yellow wire, which is going to the cathode. Okay, see how that works? It's a polarized cap now, so we have to have it in the right direction. All right, hang on. So 1 UF with 1.8K resistor. Let's see what that sounds like. Okay, let me play with the resistor with this cap and see what we can get. The higher we go with the resistor, the more kind of fartiness comes in. I'm noticing a lot of those bass frequencies that make it sound muddy. Okay, just one. Let's just do 1K. I don't know. Let's do 800 ohms. Nah. 1.7, 1.8. I'm going to leave it there. Let's try something else. Let's try this 0.68. Now again, this is only one gain stage, so if we alter the other gain stage, we might be able to get this thing sounding really good. But I want to settle out on something here that I think sounds halfway decent at least. Pretty good. Pretty good. Let me switch back to this, which will get me lower than 0.6. It'll start at 0.1 and see if I like that better than the 0.6. Okay, switching. Again, there's no high voltage here, so it's very low voltage. I feel like this sounds a little cleaner at 0.1. Is that a 0.1 or a 0.01? That might be 0.01. I can't remember. It says 0.01 scale, but I thought that this was 0.01 and then it went all the way up to 0.1. Hold on. Let me check it. What is this? This should be 0.1, right? Oh. Hold on, let me turn the amp off. Or, I didn't need to do that. Just disconnect it here for a second. Yeah, 0.1. Okay. I just want to make sure. Okay. think you can add more with these knobs. So you could say start at 0.1 or 0.04, 0.022. I like that better. No, hold on. These aren't going to do much down here. It's really still 0.1 as the main value. I like this so far. So far, that seems to be the best combination. This 0.1 resistor, it's still got a lot of bass and oomph, but it's not as farty. You know what I mean? Now that I've settled on this, let me switch up back over to the stock, so I can show you the difference now. All right, so let's play it like this for a sec. God, I'm out of tune. Sorry, but. Sorry, I'm still out of tune, but I really need to tune up. Hang on. Okay, hopefully this is a little better. Okay, let's switch to original. Shit, where'd that one? Sorry, I lost the lead here. Okay, let's all we gotta do is connect cathode now back to original. Here, see what it sounds like stock. See what I mean by fartiness? It's very blocky sounding, like blocky distortion. Like it just doesn't sound good. There's not a lot of breakup. There really isn't, and that's part of the reason why it's tough to really dial this in, I think. But the little break we have, we can fine tune. It sounds a lot better. Let me grab another guitar real fast. This is just a Fender Strat. And grab something with a little bit more oomph. It's a Charvel guitar, but it has a really hot pickup. It's a passive pickup, but it's really hot sounding for metal, right? So Let's see what this sounds like. That's a little hot, I think. See, it's even hotter, so it sounds blocky. We've cut the master back a little. No, it's still farty. Hang on, I'm also plugged into this second input jack. This one I think is supposed to be a little hotter. Wow, yeah, it's even hotter. Hmm. 1.5K sounds okay with this. Hang on. Let me try some. Positive, negative, 1 UF cap. I mean, there's more distortion, more breakup with the 1 UF cap, but it's not necessarily better distortion. I think to really get this tuned in good, I think we need to do something with the first gain stage as well. I was hoping this would be like a dramatic night and day. It's better a little, but not as much, and they're not doing much with that first gain stage either. They only have a resistor on it, no cap, nothing. So, hold on. mean, breakup sounds decent when it's just a little bit, but I'm trying to get this thing a little, like, when you really crank it up, I mean, these things can cook. I want that distortion to be a little less blocky and weird. So, hang on. That sounds good. The volume's only like half, though. Alright, well, I think what I'm going to do now, I mean, I've spent a lot of time on this. Hopefully it's cool for you to see what I'm doing and playing with things. I think I'm going to need to play with a little bit of this off camera so you can see what I come up with, because I could spend hours tweaking things until I get it where I want. But I really feel like at this point, separating that capacitor is probably going to be a good idea, so I can have its own one. Whether it stays the same value or not, at least I can make it switchable. The other thing is, this first gain stage, nobody's done anything with it, except put a resistor on it. And I think that really is making it sound farty as well. It's a combination of things, right? Let me just try one thing. Okay. One thing before I go here, and we'll take a break and come back and do something else. If I connect, this is the first cathode, okay? The first gain stage. We were working with the second one. I'm just going to leave that resistor in place, but I'm going to put a cap around it and see what happens. I still think that resistor value is a little too high, but let's put this 0.6. A lot more distortion, right? Hang on. It's almost too much. How about this? How about these? What if I just share the same? I don't think that's going to work. Maybe. Yeah, it's too much. Okay, hold on. I'm getting carried away. Let me do this. This resistor, capacitor. Let's take this off. This on. Just trying one thing. I'm gonna put the original. Shit, that's ground. I got so many wires, I don't know what the hell I'm doing here. Hang on. I want to put a cap. I just want to put a cap around the first gain stage, and for now I'll just put the original one back. See what I mean? I'm gonna just do this. Okay, original's back. Now that's the sound I'm looking for, but I don't have the volume turned all the way up. That's okay. I mean, it's close to what I'm looking for. It's just backed off a little bit. Still farty. That's this. Alright, I'm not going to waste your time. I already have, probably, but anyway, if you're watching this still and haven't skipped ahead, thanks for sticking in there. I'm going to play with this a little bit off camera because I think if I get the right combination, I think I could get this sounding really good. And while the amp sounds amazing, and you know, I really don't need to do this, I would personally like to make it sound better when I play the amp really cranked. Like, I think I can get that blocking distortion to be a lot less blocky. It's just going to take a little bit more, probably combination of resistor cap on both of those stages to get it to a sweet spot. Now the voltage does matter too, but the voltage here is at a pretty average voltage on this preamp tube for what it is, what it's doing. I'm not going to mess, I don't think I'm going to get into messing with that, because otherwise that would require us to change some of this B plus stuff going to that, and I don't want to do that. Changing these 100K resistors, for example, could potentially make it sound better if we upped them a little bit to drop that voltage down, and we could get into more of that sort of Brown sound, Van Halen kind of thing, potentially. But I think the most important things is these cathode values. It's just not designed to have a great breakup sound, but I think I can make the breakup sound a lot better. So I just need to find the right combination, and then maybe I'll come back once I got something a little better. Okay, ladies and gents, I've got a demo of this for you. So I have been tweaking this, let's call it the boosted mode, the higher gain mode that I want to add as a feature to this amp. And I showed you a lot of different things where we were putting in different capacitors and resistors but we were doing it on the basis of separating the second cathode of the V1 tube with the shared cap and resistor that's over here on the other 12AX7 tube that's responsible for helping to oscillate the signal for the tremolo effect. I realized that the way the circuit is made, we can't separate those and still have the tremolo effect work, based on the way it's designed. It could be rerouted a different way and we could still make it work and separate them, but I'm not going to get into that much kind of modding this amp. I still want to keep it original, right? I still want to be able to play it original, keep it original. But I figured some other cool stuff out, so I started playing with the first gain stage. So there's a 4.7K resistor going to ground from the cathode of the first preamp tube gain stage. Okay, that's all it is. No cap on it or anything. If we add a cap to that, we can add more gain. We can add more volume, more gain, more oomph, right? So that's good. Now, when I added a cap, it really enhanced that flubbiness we were hearing in the low end. I called it the fartiness, right? So then I thought, okay, well, what would be causing that? So I looked a little further down the circuit and I realized on the plate of the V1 tube for the first gain stage, there's a 0.01 cap that's going to the volume pot. Now that's letting a lot of bass frequencies through. And while those bass frequencies in that particular range sound really good when the amp is clean, when it's boosted, it's way too flubby. Okay, so I thought, okay, well, that's cool. What I could maybe do is come up with a combination of changing that resistor when you're in boost mode and adding a cap over that 4.7K resistor. And I even played with changing the resistor as well and the values and stuff, and that didn't really make a difference. But basically swapping, adding a cap. Okay, I'm sorry. Let me start over. Stock would be there's a 4.7K resistor in the first gain stage, and then in the input part or the cathode part, and then there's 1.01 cap that goes out to the volume pot. Okay, then there's the tone stack after that that's filtering out the frequencies to make it brighter or darker. Okay, that comes after that stage. But if I add a cap to this resistor, then I realized I can really increase the gain. However, that flubbiness also increases. So I thought, okay, let's change that cap value to something lower to filter out some of those heavy bass frequencies that's making it sound flubby and make it sound a little more crunchy, right? And I was able to successfully do that. So if I design something here for this, then what I would do is I would say, okay, stock, it would be the 4.7K resistor with no cap on that, just leave it stock, and the 0.01 to the volume pot. If you flip a switch to boost the gain or make it sort of a high gain mode, then you add a cap to the 4.7K resistor that wasn't there before, and you change the value of the one cap that's going to the volume pot, the output of that gain stage to the volume pot, to something else to filter some bass frequencies. And that method seems to work really well, even without touching the second gain stage, which has that shared cathode, cap, and resistor. So here's what I have right now. I've got the Fender Strat, not the Charvel guitar, so it's a little less crunchy, but still sounds pretty good. Here's what it sounds like with the mod Enhance. This is volume all the way up, tone all the way up. Let me turn the volume just a little back. Okay, here's that same configuration setting, but back to stock. I take this cap off, and I change the cap back to an 01 cap. Hear that fartiness? So let's put the cap in. That's going to give it more gain. Still farty, so we're going to switch to a lower value cap to the volume pot. If we go even lower, we can cut some more of that, but I don't think it has enough bottom end. Okay, hang on. So here's the .01 cap. The .001 cap. Let me try .022. Back to .01. So I don't know if you can hear that, but the amp is really overdriven at this point. I mean, you might not be turning the volume all the way up, right? If you cut it back a little bit, it does get a little smoother, which I may do a little tweak possibly to. I have to look at what this value of this pot is. You know, just by cutting that 10% or so might make it so that when you do turn it all the way up, it stays pretty smooth. But it's a pretty cool gradual breakup in this new high gain mode. So hang on, something doesn't sound right now. Some sense. What's going on? Something's not right. Okay, it sounds a little better there, but I feel like with all these wires and all, we're losing a little bit of signal because there's so many things clipped in, and it's going to sound a lot better once something's actually solidly soldered in there. But let me switch it back to stock for a second. I want to make sure that the cleans still sound like what they did. So we got 0.01 step. Here, I know what I'll do. Let me do a true back to stock. That would be this back in. Let's take this off. I got so much going on here. All right. Here, this is what we want. We want this here. Okay. We don't even need this on. Let's make sure we're good. Yeah. Okay, so back to that farty sound, that original stock farty sound. That's only when we crank it, though. I think the cleans sound great. The cleans sound great in that setting. But I definitely think it cleans up a lot better. And I'm almost wondering if I'm getting a little bit of clipping going on coming into this video, and you might not be getting the true sound of this. So I'm going to take a look at that real quick. But I have an idea for this. So I like having a boosted mode on this particular circuit. I think it sounds really cool. If I can leave the amp cranked, right? Like my ideal thing would be if I was using this, let's say in a live situation. Let's say I had this little combo amp, 5 watts, and I had a speaker. A microphone hooked up to the speaker to go through the house cabs or whatever, right? It'd be cool if I was playing clean, I could roll my guitar volume down, and leave the master all the way up all the time and roll it down to low when I'm playing cleans, right? But if I had a foot switch option to kick in that boost for, let's say I'm doing a solo and I really want it to be distorted and louder, and roll my volume up on my guitar, hit a button, and then swap those 2 caps out that I was saying for a different set of caps. And that way, when I have the amp all the way up, essentially, or close to all the way up, I have that nice clean distortion and it doesn't sound farty, right? I mean, we're doing a lot with a little, right? We're trying to do a lot with a little amp. I mean, this is not a complex circuit. That if we added a lot more to this and got crazy with it, we could make it sound a ton better, I'm sure. But we're just working with what we have, and I'm trying to do the simplest enhancements to make it usably sound good, right, when I'm playing loud or distorted. Because I think this has a lot of potential. I mean, the way it's designed and everything, I don't have to change 15 different parts to get it to sound like the way I wanted it to sound. I literally just had to change it and swap in 2 caps. Well, add 1 cap here, and then add and change a value of 1 cap there. And that's something that could definitely be put on a switch. That could be switchable, if done right. So, and then I'm not changing anything else. So, and the fact that I mentioned the word foot switch, I think it would be really cool, because this amp doesn't have a foot switch option. I think it could be foot switchable. I think possibly. I'm going to look into that. If it's not too crazy, I might think about doing it where there's like a little jack I could plug a foot switch into and just switch that on and off, that feature. So I got like a boost, right? I got this going at cleans. I roll my volume up on my guitar a little more, and then I hit that foot switch, and I'm instantly into this high gain mode with a decent sounding breakup. I would like to connect this to its original speaker and try that breakup, because this combination might not sound as good through that speaker. But I do have a feeling by cutting some of those lows, that flubbiness should go away even on the internal speaker. But I need to try it. So before I commit to doing that, I'll probably try that off camera and see if it sounds decent, and then I'll look into drawing up a little plan so that we can figure out how we're going to do it and find out if it's going to be easier or not to make it foot switchable. But yeah, I think that would be really cool. I'm having second thoughts about adding a enhancement for the tremolo intensity effect, because I feel like now that I've been playing this a little bit, this tremolo intensity is not that bad. It really isn't. It's not like others I've heard where the guitar signal totally drops out. Like, let me do this real quick. See, the guitar signal's never completely going out in that oscillation. It's never completely dipping to the point where it's completely silent, which a lot of amps that have this feature without a what do you call it, intensity knob, like a Fender, I think, what is it, a Fender Vibro Champ has the speed and intensity. It's cool to be able to adjust it, but it's not an effect I would use all the time, and I don't think anybody would use all the time. This might be good enough stock as it is. I mean, adding an intensity is an easy thing, but do I even really need to? It's not. If it was going to complete zero volume in those oscillations, I might, possibly think about adding that. But I'm having second thoughts. I may do something else. I may do something different that might be more usable for this particular circuit, because this really isn't bad. I don't know. I think it sounds pretty good on its own. So, all right. Well, back to the drawing board. I just wanted to check in here on the video and demo kind of what I'm coming up with for this gain circuit, boosted circuit. I may tweak it a little bit more, but I'll be back. I'm gonna think about this and see if I could make something easily switchable and or foot switchable for that. And in the end, after I try it with a real speaker, maybe I'll tweak these values a little bit. But here's what I have so far. So far, I'm leaving the 4.7K resistor because I have tried different values and the sound wasn't right. A 0.22, not a 0.02, but a 0.2 capacitor, non-polarized. I tried the 0.6, which is a typical Marshall value in like a JCM 800, the first gain stage of 0.68, right? So it's 0.6. This is 0.2. I felt like this is a little too much for this circuit and how much volume is going through that first gain stage. So this turned out really good. I tried a 0.1. I didn't like it. I felt like something just didn't sound right. And I've even tried, up to a 1 UF or a 10 UF. That's too much. Definitely. The lower we go, kind of the more it gets smooth and not so harsh. So I like the sort of smoothness I was getting out of the 0.22, but it still boosted it quite a bit by adding it in there. So they didn't have a capacitor on the cathode of the first gain stage. So I'm adding that on boost mode. It's saying, enhance this, bring in some volume, bring in some oomph, right? it's adding some more gain to that stage. The 0.01 cap that's going from the plate, got to keep in mind that one does have high voltage on it, but it's blocking all that high voltage before it gets to the volume pot, and it's soldered directly to the volume pot from here. So I was using this capacitance box to do that value and then swap in a lower value. So I tried a 0.001 instead of a 0.01, 0.001, and that really cut a lot of those flubby bass frequencies. So the fartiness was going away. And then if I go lower and try to 0.0001, that was not enough bass frequencies, I felt like. Yeah, it sounds very crisp, but it's almost too ice picky, right, sounding. So maybe I'll level off at 0.022, sorry, 0.0022, or even like a 0.0068. I don't know. I'll have to try it with the speaker and see. Like this 0.001 might not have enough bass to it when I really crank it through the speaker. But I know that this 0.01 cap that's in there now, cranked up, it's farty. I don't like it. I think if I'm going to add more distortion to this gain stage, we need to bring some of those bass frequencies out, and that's what this thing will do. So you can see what I'm doing is not related to the tone circuit at all. I mean, it is, but the tone control, I should say. The tone control is a little different. We're bleeding some of these frequencies, this 0.0047 cap. It's going through this pot to bring it down to to filter those, but that's more of a high-end frequency filter, right? So it's letting the high frequencies through, or it's cutting the high frequencies out. That's why it goes from dark to bright when you turn the tone knob. That's just how most of those single tone knob things work. It shunts the high-end frequencies to ground. So without getting crazy and having a separate bass, middle, treble type of a tone circuit in this, we're going to leave it the way it is, not mod it, let it do its thing with the cap it has and the pot it has. But we're saying in high gain mode here, we're going to filter some of those extra bass frequencies that this thing is just not able to filter out, right? That's doing more of a high end. The low end we couldn't control, so changing that cap value from a 0.01 to something like a 0.001 is helping with those flubby bass frequencies. So yeah, that's the plan. I'm going to see if I can come up with something that's cool and switchable, and maybe even foot switchable. Okay, different experiment here. I've got the speaker cab, the original speaker, hooked up with this experiment, and it is sounding really good. Actually a lot better, I think, than me using virtual speakers. Although I can probably change those virtual speakers and get a better sound, which I probably should do for the rest of this video. But the cab is on the floor here, so this is the original stock setting, okay? Tone knobs all the way up. Turn the volume up a little. Now I'm going to switch to my hottest pickup, which is the bridge pickup, okay? So that's going to have more breakup. Okay, not bad, but now we're going to give it more juice, so the volume's all the way up now. Tone and volume all the way up. Okay, so we still get that little bit of flubbiness. It's not as bad through the original speaker as it is, I think, coming through the computer. But let's go ahead and change this to... Alright, so we're going to... First, I'm going to put the capacitor in circuit. So here's without it. So we're going to put the capacitor in where the first gain stage is. There's that 4.7K resistor. I have that set on this decade box, but the capacitor, the 0.22, is not in circuit yet. So this is still stock. Now let's put that in. It's gonna click and pop here for a little bit, but come on. Come on. Ah, hold on. So a lot more oomph, right? Without it. Okay, add it back. Okay, you still hear that fartiness? Now let's switch the capacitor going to the volume pot to a 0.001 from a 0.01. Switch it back to the original capacitor. The new one. And what I think I settled out on is actually 0.022. Sorry, 0.002. Which gives it a little bit more oomph without getting too distorted. It cleans up those bottom notes, you know what I mean? It doesn't make it sound as like it's clipping out or blocking. Now I think this is too much, this 0.0002. We don't hardly get any bass. So this one to me sounds pretty good. And then if we adjust the tone a bit, so it's not quite as kind of tinty and bright. I just think that cleans it up so much more. So we got a little more drive and a cleaned up bottom end. That's the only real difference here. Setting it back to the way it was would be like this. You can really hear that blocking distortion on the single notes. See how that cleaned that up? Just changing that one cap. Add the cap in for a little extra boost. Now this is with the amp cranked, right? So it doesn't have to be that nuts. Oops. So with this pickup setting and a little less master volume, and I'm on the boosted mode, right? It still sounds really good, clean. But it's not quite as thick as it was before with the clean. So now if I switch it back to stock, you can hear how how much this cap really makes a difference in how much volume comes through. But it sounds bassier now. So I like it stock for cleans. I really do. I think it sounds very round, very full. Really good for a little 5-watt amp. I mean, it's pretty freaking loud. But crank it up, get the distortion going, and it just, that's where it starts to fail. But changing two values, or well, literally adding one cap to boost the gain a little, and changing one value of a cap down to a lower value lets filters out more bass frequencies that are kind of making it flubby and blocky, and that really tightens it up, and I think makes it sound really nice for distortion. So if you are using this in a live situation, and you had a foot switch, had that option on a foot switch, it could be really cool because you could leave the amp cranked, you know, set your tone where you want it. For me, it would probably be like on about 7, because I do like some of that chime, but not too much. And then I could roll back my guitar volume, which is what I'm doing here for my clean. And if I wanted to rock out, hit a foot switch button, engage this, and knock this cap down a notch. Actually, I think it was 0.022, wrong value. Actually, I might like, that was 0.003. This maybe 0.004 might be cool. Nah, it starts to get blocky there. So that 0.022 seems to be the sweet spot, at least with this guitar with these pickups. So, you know, you got to average out what kind of guitar you're going to be using. So yeah, you could switch that on the fly pretty quick with your guitar, especially if you had a foot switch. And I don't know, it doesn't necessarily need a foot switch, but some type of switch somewhere would be cool without modding it. Again, I love it clean the way it is, but I really like the boosted sound. If you're gonna crank this thing, why not make it sound good cranked, right? So I think I got my plan here. I just have to figure out how am I gonna do it. And I'll come back with a solution on how I'm going to do it. And like I said, it's pretty cool. I wanted to check that before I committed to adding this feature, but I feel like it's going to be a really good one. It sounds amazing through the speaker, even better than it did through the computer, but I also think I need to change some of my computer settings. I've got probably got some weird cabs that just are meant for, you know, they might be like 412 cab, big bassy 412 cabinets. That I had set from something else I was doing. But if I just put like a single 12-inch or a 212 cab, that might sound a little better. So I'll play with that. But anyway, yeah, very cool experiment. Okay, guys, I have been away for about 4 days. A lot of busy stuff that I'm going through, but I'm back, and I'm been thinking a lot about these mods, not mods, but enhancements I want to make to this amp, keeping it fully original. And the thing I want to get out of this thing is really just a really good gain sound, like high gain, rock and roll, balls to the wall kind of a sound, right? Best I can with the circuit that's here without completely fudging up the circuit and changing it into something else, right? So I want to be able to switch things on and off, go back to stock. So as you've seen so far in the video, we've added a cap around the input stage on the cathode of the input stage, right? The first stage, the 0.22 UF cap. We've changed the output of that stage, which was a 0.01 capacitor going to the volume pot, which was letting a lot of bass frequencies through, and while it sounded good clean, it didn't sound so great when it was pushed. So playing with the decade capacitor box, I settled on a 0.002 or 0.0022 UF cap, which cut out a lot of those boxy frequencies and made the distortion clean up a bit when I'm playing heavy. Another thing that I did was I've been looking at this bias and realizing that this 150 ohm resistor, I think I'm going to change it just for stability. And then I was thinking about stability, giving it more stability, which if you've ever seen some Fender amps from the 60s and 70s, you'll notice that if it's, well, let me take it a step back so you understand. This is a cathode biased amp, so a lot of those amps in the Fenders had an adjust pot, right? If they didn't, then they might have been cathode biased as well, depending on what the actual model was of that amp. Point is, this amp is being biased by one resistor, this 150 ohm resistor, and while the bias number looks good, it's at maybe 90% dissipation, and it's a Class A amp, and that's totally fine. We could go up to 100% dissipation if we want, but that, to me, doesn't even... I tried it, and it didn't really sound any different, so I'm going to give it a little bit of leeway and just leave that in there. And I thought about this. A lot of amps, they put a capacitor around that resistor, like a cathode bypass resistor, very similar to something like that, where if you put a cap around it, it can stabilize that bias a lot more. Because what happens is, as you play notes in an amp, these filter caps are draining just like a battery would drain as you run something on a battery, and then they charge back up again because they're plugged into the wall, right? So it takes them some time to recharge and whatnot. Well, it's kind of a similar thing is happening with bias. The voltage is dropping as you're playing it and then going back up based on when things recharge. And these are not very high value capacitors. These are 10 UF and 22 UF. So in more modern gain amps, you know how you get that sort of more stabilized sound. It doesn't dip out. It doesn't have sag. A lot of these old vintage amps have sag. I kind of like that for this, right? So I don't want to change these cap values or have a way to switch them to higher values. Plus, that could be very dangerous because you're dealing with high voltage with these caps. I don't want to make caps switchable. However, adding a cap to this resistor for bias can help to stabilize it, and it does make the sound more stable, the volume, because what happens is as you play notes, the volume kind of drops down a bit, and you can keep that volume up higher to stabilize this bias and keep it from fluctuating so much as you're playing, right? So we're not changing tone, we're not changing gain, we're not doing anything there. We're just, if we add a cap, we're going to get more stability. So listen to this. I'm going to play the difference without it. And right now, the amp is set totally stock. I don't have any of these enhancements in. It's just cranked up, and it's a little boxy sounding because I don't have any of the enhancements in, right? But listen. Let's put that cap in on the bias. Back in. out. So hopefully what you could hear is that the volume, it may have appeared to sound louder. Technically it wasn't, but it was louder in the sense of being more stable volume throughout the course of playing those riffs, right? So when I strike the note, it automatically dips down the volume without this capacitor. Now, this is a very common thing to do in a cathode biased amp, is to put a cap around that resistor to stabilize the bias. I think I'm going to do that and leave it there. I could make it switchable because it does change the sound. It doesn't sag as much. There's still sag there. Like, there's still time that these caps have to charge up. But the bias in the power tube, since it's a Class A amp and there's one power tube, is definitely more stable. And I really like that. I feel like it's not dipping out and we have a good stable volume. So what value am I using there? So I've got a 100 microfarad at 100 volts. Now, this voltage here doesn't get up past like 10 volts on this bias, right? So I don't have to have a cap this big, but this is a typical value that a lot of people put in Fenders where they had a cap like this that was 20 to 25 UF. And a lot of people will now, today, put a 100 UF cap in there. Why? Well, because it stabilizes it, but if you put a low value cap in there, you can risk filtering out some really low bass frequencies with a lower value cap. If you put this higher value cap in, you're going to let those bass frequencies come through and you'll get the natural sound of the amp without filtering anything out. And most of those frequencies are down in the sub frequency range, so you're not going to hear too much, but a higher value cap has more capacitance. It's going to stabilize it better. I just prefer to use a 100 UF cap in a situation like this with a cathode biased amp. If, like I said, if I put a lower value in there, it could potentially alter the sound, whereas this is not really altering the sound, the tone, the frequencies that are coming through. It's just stabilizing those frequencies and appearing like the whole amp just got like a notch or two louder, but that's just because the volume's not dipping out like it was. Okay, so I was thinking, because it is such a difference in sound, hopefully you could hear that maybe that could be a switchable thing, right? They didn't put one in here. They didn't think it was necessary, but nobody was trying to drive the amp like I am back in the 60s, probably. I mean, maybe they were starting to when this was made, but it wasn't until probably the late 60s, early 70s, and you get the Black Sabbath type bands and all that, and you wanted to have some of that overdrive, that distortion sound, that gain, right? So I want to make a really good gain sound. I feel like it definitely improves it by adding this cap, and it's a more reliable bias if we do this. So I'm probably going to add it, or I'm going to make it switchable, because yeah, it doesn't need to be there. You could see I was switching it in and out of circuit, and now I want you to hear this thing with all of the changes that I've made to play in a high gain mode, so to speak, right? I'm going to add this cap in. I'm going to swap the 0.01 cap with the 0.002 cap. And then I'll clip in this bias stabilizing capacitor, and then you'll hear what the gain sounds like. And then I got one more thing that I might decide to do with this amp after that, and I'll tell you what that is in a minute. But let's hear how this sounds. So amp is stock. I'm going to add each component, and we'll see how that changes the sound, and then we'll get on to the actual doing of things here. All right. Oh, by the way, I did change the virtual cabinets that I'm playing through. Hopefully they sound a little better. Maybe you might think they sound a little worse. I think it's more of a personal preference thing, but these are Celestian. Now I know exactly what they are. Hold on, I was using some kind of Mesa Boogie cabinets, which are really bassy and thick, and for an amp like this, I don't think it was really appropriate. So now I'm using these Celestian G12 T75s, which are pretty much for high gain type stuff. It's pretty common in high gain amp cabs. But anyway, it's mic'd with like a 421 and an SM57, and there's like one variation of that miking going on the left and one different variation on the right, but they're both the Celestion G12 T75s. I thought that sounded a little better and a little clearer than it did with the old other settings I had. So I'm still using the Fender Strat here, but take a listen again. We'll start again. Okay, add in the cap on the first stage, the .22 cap. So that's literally just adding gain to the circuit, more gain. Now we're going to change the .01 cap. Give me a second. Sorry about the feedback. We'll change the .01 to the .0022 to cut out some of that boxiness. Now, the bias stable cap. Let's take that off. So I kind of like it better with this cap off, with this particular guitar sound and these pickups, but I could see where adding that stability with a different guitar, or if I'm adding a pedal or something, that could be really helpful. So I may make that switchable. Let's listen to it one more time to hear the difference. Yeah, I mean, it sounds like it's driving it harder, but it's just more volume, right? It's more volume going through the power tube, so I think there may be a little bit more power tube breakup, right? There's not more gain in the preamp stage by adding this cap to the bias circuit, but it might be letting a little more stable volume, higher volume go through the power tube, which is giving us some power tube breakup. At least that's my theory and thoughts. I may be wrong, but in theory, it stabilizes it, it lets more volume in, and I can even see it on a VU meter going through my computer that it is a little tiny bit higher volume than it was without the cap. I can literally see it on a meter. Like if it's at like negative, 6 dB, it's up to negative 4 dB now, right? Something like that. So it's a little higher. Okay. So I like this, and I think I've decided against making this foot switchable. Anything foot switchable in this. I think it's too much for this amp. The problem is the only thing I feel like I could safely make foot switchable would be this first cap, the first thing we added, because there's not any high voltage going to this. And I literally could just keep this cap connected to the positive end of the cathode on V1 and then just ground it out. A foot switch, the easy way to do a foot switch is to make something go to ground and take it off of ground, right? Put it to ground, take it off of ground, switch it on, switch it off. This would be easy to do that. And that's going to add more gain. That was the first thing I did, was add boost of gain. So I could make that foot switchable. But to make this and swapping out this other cap, which does have high voltage on one end of it, it's got about, let's see what it has. It's like at this pin. It's 170 volts. So it's doable. It's not that dangerous. It's just I would have to make sure that it really is secure, and maybe I don't want to take the high voltage all the way down to another panel that I might create with these switches on them. Maybe I leave the high voltage inside here and just run it after the cap. Like have two lines going from one cap to a different cap. I don't know, something like that. But if I do double things that have to swap in and swap out, that's going to be hard to do on a foot switch without using like relays or something. So I thought about it and I'm like, you know what, screw this. I'm just going to make a control panel maybe that goes on the back. We can have first feature, switchable, boost. Let's boost the distortion, right? Gain boost is the first one. Second one is like a voicing, like a bass voicing and a less bass or treble voicing or whatever, and that would be swapping the second resistor, right? That way, if you're going to play in a high gain mode, maybe you do want that bass. Maybe your pickups sound really thin, right? And that way you have the option to turn that voice 1 or voice 2, right? And that would be this cap swapping two values. The other thing I could do is I could put it on a rotary dial, which would allow me to pick different caps, right? I could go from a 0.01 to something even bassier, you know, like a 0.1, or go all the way down to a 0.02. So I haven't thought about that, but yeah, I could have multiple settings for that. I could also make multiple settings for the amount of gain here. This 0.22 cap I think sounds the best out of all the stuff I tried, but you know, we could put that on a rotary switch and have multiple caps on it. I don't know if I'm going to get that crazy with this, right? I'm dialing in what I think sounds the best out of all the combinations of things I've tried. So why make it super unlikely that somebody would choose something that doesn't sound as good as the one that I've worked on for so long, right? It's a toss-up, right? Plus, how much money do you want to put into this? How many parts do you want to put into it? You know, and then it will be harder to maintain down the line when you have to potentially replace a bunch of caps or sure them up or whatever you're doing. So probably we'll have at least those two switches: boost the gain, have a voicing switch. Probably put this maybe on a switch because I do like the way it sounds to tighten things up and bring that volume up to more stable with the bias. And it didn't have it on there before, so why not allow you to take it out? Because in some cases I feel like it might sound better without it, actually. Like that sag is kind of nice and natural. Okay, the last thing I haven't talked about yet that I thought about was this might be a really good candidate to do a diode rectification versus tube rectification. What does that mean? Well, the amp has that 6x4 rectifier tube. And rectifier, when you're doing the rectification of the AC coming from these high voltage leads, these two red high voltage leads coming out of the power transformer, they're AC, right? So how much AC do we have? Well, let's take a look. Just so you know, because it's going to be important how much it is in a minute. So I've got my meter switched to AC volts, and right where it hits the this pin here where it's connected, or I can do this pin because they're both about the same. We have 255-ish, 250 volts of AC coming out of the transformer, right? And then the tube is rectifying it to DC. And if you go over here to this pin, this is where the DC comes out of. And we have about 285 of DC, right? So we have a little bit more DC than we had of AC. All right. But that's the tube doing the job of the rectifying. The tube itself is changing. It's almost like diodes inside of the tube, changing the AC over to DC. Well, with a tube doing it, it's definitely going to have a little more sag to it. It's going to take it a little bit longer to produce that DC, to change the AC over to DC, as opposed to actual physical diodes, solid state rectification. And this is a common thing in a lot of amps. I mean, a lot of Mesa Boogie amps that I've owned and worked on have had a tube rectifier switch versus diode. And who likes to use the diode? Mostly metal players, like rock players, metal players, because there's not as much sag and it's definitely a tighter response and it sounds better for those power chords and chunky sounds and high gain leads and all those kinds of things, right? So I think it might be cool, and I haven't tried it yet, but I may tack in a couple of diodes just to see if what it sounds like. What is that going to do to the circuit? Well, one, it'll take the tube out of it if I make it switchable, so I can say, hey, I don't want to use the tube to rectify my sound right at the moment. I want to make it diode. It's going to raise the voltage, right? So we were getting 285. It might go up high as like maybe, it's hard to say exactly, but maybe like 300. It's going to go up a little bit when I put diodes on there. So right now it's 280, 283, right? And over here on the first gain stage, the very first plate of V1, I have 183 volts. This might go up to like 200, right? 195, 200. What's that going to do? Well, it's actually going to probably give it a tiny bit less gain, but it's going to smooth things out, and it's going to be a faster, tighter response on picking the notes. So when you're playing really harder, faster sort of rock and metal, you want that quick response and that less sag going on. The amp's going to feel more responsive and more alive and energetic. But if you're playing blues, if you're playing, clean sounds, jazzy stuff, whatever, something less distorted, the amp might feel too stiff for you. It might feel too stiff. So put it back to tube rectification and also take this cap out of the mix, and that amp is going to have a lot more sag. It's going to have a lot more smoothness to the feel, less tight and sterile, and you know what I mean? It's going to push and pull. It's going to give. It's going to be like a love-hate thing. Like you play a note and the amp's going to get mad for a second because it's like, ooh, you just caused me to pull a whole bunch of energy, and then the caps charge back up within a few seconds, and then they drain back out again when you hit another note. So that response is going to be very slow without the way the amp is currently. And that sounds great for vintage style music and stuff, but for a more modern sound, for rock, grunge, progressive stuff, any kind of metal, hair metal, those kinds of styles, which is kind of what I'm kind of going for because I'm adding this gain. I want to be able to play this amp with a decent sounding gain. The tighter we can make it, probably the better. So I'm going to try that and see if it sounds good, and if so, then I might add that as a switchable feature. All right, so long story short, 4 switches so far. It's going to be like a little control panel of I don't know, allowing you to change the responsiveness of the amp, the voicing of the amp, and giving it a gain boost or not, kind of a thing. So it's going to be like 3-in-1, 4-in-1 kind of a feature. So while it's cool and you're very flexible, would be very hard for me to make a foot switchable mode without getting into all kinds of crazy wiring and relays and circuitry and stuff. It's definitely possible, obviously. I'm not going to say it's not possible, but how far do I want to take this little guy? Not that far, right? But if I had a couple little mini switches on the back of this thing, I could really make this an awesome little studio monster. If you want to play a totally rocked out Class A amp and record it, they do sound amazing recorded, even with microphones and the original speaker, or hook up an external speaker cab. So yeah, that's my sort of plan with this right now. I think that's going to be plenty of enhancements. The goal would be to have a very customizable, overdriven sound. I want to make it as customizable to my rock choice of sound that I can with what's here already, right? The tubes that are here, the circuitry that's here, we're not going to change any of that really. We're kind of just adding some things and allowing you to turn them on and off. Still be able to play it totally stock. I also want to add 2 speaker jacks, so I'm thinking about building a little panel that's going to have the boost switches, diode, rectifier, the voicing switch, and be able to just sort of modify that and then plug into external sources as well, right? Easily, without you having to unsolder wires and unsolder wires and whatnot, like we had to do from the speaker, because it's just hard soldered to the speaker. So in this case, you'll have actual jacks that you can plug out. So yeah, that's the plan so far. I don't think I'm going to alter it from here. Maybe as I actually wire it up, I might say, you know what, this value sounds better than that, and then decide on a final value. But otherwise, I think that's the way I'm going to approach this. So I really wanted you to be here on this journey to play with it and see how this is kind of what I go through when I have to design a circuit. I'll play with different settings until I get the sounds that I want. You have to really and then you really start to understand how these tubes can react to different value caps and resistors and even voltages, right? So keep in mind, on these preamp tubes, not on the power amp tubes, but on the preamp tubes, that 180 volts or so, if you bring it down to, like, say 160, you're going to get more gain out of that tube. It's the lower the voltage is on the plate, the more gain you're going to get out of it. But it might not necessarily be the kind of gain you want. It might be a little, you know what I'm saying? Like Eddie Van Halen, when he had his Brown sound, he had a Variac, and he was able to dial the full voltage of the entire amp down, 20 volts or so, or whatever his sweet spot was, 25 volts, something like that, which brought all the voltage down. But where he got to the point where he found this sweet spot, and it was probably, a lot of it was due to the preamp stages that were giving him his gain sound, to where he got this really sweet sounding Brown sound, as we call it today. The Eddie Van Halen sort of guitar sound. And that was probably due to lowering the voltages. Now, when I add the diode, it's going to increase the voltages, but it also is going to make things a little bit more stiff and stable, just like adding this cap did on the bias, but just in a slightly different way. So I feel like it might be cool because, we have a lot of gain going on here, but it might actually make the gain sound a little bit more natural and a little less overdone, right? Because right now I do feel like it is kind of an overdone sound, but it's a pretty cool overdone sound. I mean, it is what it is. It's a Class A amp, and I'm not going to get into changing the resistors that are on here and the caps. Like, all these values I'm going to keep original. The only thing I'm really doing is clipping in a couple of things, allowing you to switch one out for another for just this one cap, because that is going to really help with the bass end of things getting flubby. And then clip this in and out, and clip diodes in and out, right? And the other benefit to having the diode rectification is, if the 6x4 tube fails, you can't use this amp until you replace it, right? If that fails, it'll also potentially take out something else. So having the solid state rectifier diodes in there will not only preserve the life of this tube if you're using it in diode mode for, solid state mode for rectification on a regular basis, but also it's there. You could still use the amp in diode mode, even if that tube fails, that 6x4 rectifier tube. So if you were at a gig and something happened with that tube, it's just another way you can switch it over to diode, and bam, you're ready to go. So some advantages there, and diodes are very, very cheap, so all we need is 2, but I'm going to actually add 4 to a set of backup diodes, essentially, because they're like pennies, right, to put these in. So I'm going to put a set of 2 to do the work, and another set next to that as a backup set in case one of those fails. We're still covered. And then obviously we have the tube, and then that'll have to be wired to a switch to say, hey, amp, I want you to use the diodes, or I want you to use the tubes to do the rectification job. So 4 or so switches, a couple of output jacks. Yeah. And this thing's going to be a little hot rod monster. I think it's going to be cool. I've always wanted to do this with one of these. I've built clones, like I mentioned before, and I was able to do similar stuff and change the voicings and whatnot. But that was my own clone, so I didn't have to worry about messing up the circuit. I could do it differently. I could actually literally just say, hell, instead of putting this part in there, I'm going to put in my own part and allow you to switch it a different way. So, I'm able to design it however I want if it's mine. But I want to leave this, I want to be able to play this stock, and we'll still be able to do that. So without ripping a whole bunch of stuff out. It's literally going to be just running a few wires, putting a few parts down on a separate panel. I think we can accomplish that. If you want to take this out, take it out, reconnect a wire or two, and it's back to stock. Let's go. All right, guys, so I've got this little control panel laid out, how I want to sort of execute this. So I just wanted to show you real quick. This is not a full diagram, full wiring diagram. It's more of a sort of a reference at the moment. I may wind up completing the diagram to show exactly where the wires go, but for right now, I just have some notes. So the way I'm approaching this is I'm planning to build this little panel on the back for these enhancements. And as you can see, I called it the hot rod control panel, because that's essentially what it's going to do for this amp. Like, I'm sort of trying to make it very flexible in how you can dial in sort of a hot rod kind of a tone, right? Like an overdriven tone, and tailor it to, you know, your tastes basically. So the way I'm designing this is, you'll see the note down here says all switches in the down position are the stock amp settings. So essentially, if you have everything switched down, these are 4 different little mini switches, and I'll show what they look like in a second. When they're in the down position, this amp is completely 100% stock. When you switch them up, then they only have basically 2 positions, up and down, right? When you switch them up, then you're changing the tone, you're adding that enhancement in, right? So starting from the right here, we have the gain boost. So that'll increase the gain. That's going to put this 0.022 cap on the V1 cathode, right? So this is just saying that this wire is going to go to the 4.7K resistor on the input jack on the ground side. And then this side of this capacitor is going to go here. And then this one will already be connected to the cathode on V1. So all you're really doing here with this switch is putting this side of the capacitor to ground. And it doesn't matter which side is which, because this is a non-polarized cap. But this is the 0.22 UF cap. Let me zoom in so you can see it just a little bit better. All right. So, and also, just so you know, this is software that's free to download if you're interested in getting into, you know, diagramming your own stuff out. It's called DIY Layout Creator. There's, you know, it's free. It's really nice. You can just go and search for components, capacitors, resistors, diodes, switches. It's pretty much got everything in it for all the main sort of amp stuff. And I think there's probably other stuff you could download if you can't find what you're looking for. But it's pretty cool. It's got 2 sockets and everything. And then you can click on each component and you can change its color. You can set the font sizes. You can change the size of the component itself. Put the value in there. So you can see I have 0.22 UF. You can do nanofarads, picofarads, microfarads, you know, whatever you want to choose. So I'm just doing all the caps in UF here. All kinds of little cool things you can do. Same thing with the switches. You can change the type of switch. So like this one is an SPST. It's a single pole, single throw switch, which essentially is just an on-off little mini switch. Or you have an on-on type, on-off-on, double pole, double throw. That would be 2 sets of tabs that you can solder to. But in this case, we're only using these 2 types, and that's why I made this little key up here so you can see what it is. SPDT. This is an on switch. It has three little things that you can solder to, because that means it's always going to be on. Whatever it's connected to, which is always the middle piece. So in this case, like this one is going to the volume pot. That means something is going to the volume pot 100% of the time, whether that's whatever's connected up here or whatever's connected here. It's never going to be in an off position. As opposed to like an on-off-on switch, that would mean it would be a 3-way switch with 3 positions, and when it's in the middle position, there would be nothing connected, nothing at the top or nothing at the bottom, right? But we don't want that in this case. We definitely want something to always be connected. So that's what these two switches are here. And these other two are just simple on and off. When the switch is turned up, these two tabs are connected to each other, right? They have continuity. When you switch it down, they don't have continuity anymore. So that's like adding this cap to the circuit. When you switch it up, now it is engaged. For over here, for this bias stability cap, same thing. The positive end of this is going to be always connected to the bias resistor on the positive side of the bias resistor. And then this is going to ground it out when you switch it up. It's going to set the ground to the negative end of the cap. So it's essentially switch it up, you put it in circuit. Switch it down, it's not connected. So you have to have both ends of the cap connected for it to be in circuit and operating, right? So that's how those two switches work. Then the voicing, I just put for now as a label just A and B. So, you know, the first switching or first down position is going to be it had a 0.01 cap that was connected to the volume pot. But when I played with the caps to find the value I liked, when the amp is overdriven, I like the 0.0022 cap. That was the 0.0022 UF. So I'm going to connect this side of the cap to, or one side of the cap to the hot side, same place as where the 0.01 cap is connected now. So I'm not going to take the 0.01 cap out. I'm going to leave it where it is. I'm just going to disconnect it from the volume pot, right? It was 100% connected to the volume pot all the time. And in this case, I'm going to solder this to the same hot side as where the 0.01 cap is. And I'm just going to run a wire. One wire is going to go here to the 0.022 cap. And then the other one's going to go to the 0.01 cap. And this one is always going to go to the volume pot. That way, you're either saying, I want to use this cap, or I want to use the one that's in there now, right? So that's how that works. So it's something is always in circuit. And the reason you might think is you said, hey, all these switches, when they're in the down position, means it's going to be stock, right? So why do you have this 0.022 connected to the bottom lug here? Well, on these switches, up is down and down is up. And I'll show you what I mean by that. When you switch the, you know, like let's just say where my cursor is, if you can see it, is pointing upwards. When it's up, these two, this one and this one are connected. This wire and this wire when the switch is up. When you switch it down, then the middle and this one are connected. So that's just how these switches work. Okay. And these are like little mini switches, and you can buy these on Amplifier parts. Well, I'll talk about that in a second where you can get them, because then I'll show you what they actually look like. And then, yeah, so the last one here is the same thing. It's going to be an on-on switch, which means it's always going to be on. That means the middle lug here is going to be connected to our B+, which is our first filter cap. And I'll show you where that is in the amp once we actually wire this up. So that means when you have the switch in the down position, that means this wire and this wire are going to be connected on the switch. So that's going to be the tube rectifier. That's going to come from one wire from the 6x4 tube. And then this one is going to come from the diodes we're going to add to those tabs on the tube. So I'll show you that. So that means when you switch the amp up, this wire and this wire become connected, right? And we can test that with continuity with our meter, but that's just how these work, and I'll show you that. So very cool. So you have 4 little switches. You could be like click, 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 and I got everything engaged to its hottest sound. And if I think it's a little too much or I want more sag, I can turn the rectifier diodes off and just use tube, and I can take this bias stability cap out and I'll get more sag, or I'll get more stiffness and firmness if I switch these two on, or a combination of the two. And again, the voicing, if you want more bass, you put it in the down position, you put it up, this 0.022 cap will get engaged. It'll cut out some of those sort of lower boxy notes, you know, like the lower frequency sort of blocking distortion that was happening, and it'll cut that out and smooth it out for our distorted sound, right? Or if you just don't want that much bass on your clean sound, you could use this. So, however you want to tailor it, pretty cool. 4 switches, easy wiring. We're going to have a bunch of wires, but most of these components are that we're adding here, these 3 things, and the diodes are all going to be probably inside of the amp. They're not going to be, there's just going to be wires going to these controls mostly. So I'll show you how I do that when we get to the wiring. And then the last 2 pieces here is I'm going to add 2 Switchcraft style jacks, actually Switchcraft brand. I think they're the best quality. And we don't need ones with a little shunt to ground. Sometimes you'll see these with 3 positions like this, a switched. See how it's got 3? That means the middle lug is a switch, which means when nothing's plugged in, then it will ground this out. But you should never turn this amp on without a speaker connected anyway. And if you did put this, then it would just be grounding out your output transformer, which is not good anyway. You always have to have a load on this amp. So you don't need this kind. You can just use a standard mono jack, and the T stands for tip. That's where you connect the positive end of your output transformer, and the S is the ground side, and that's going to go to ground or connect to your ground of your output transformer. So all we got to do is wire those in, and now we have 2 parallel things. And then on the output transformer itself, I'm going to have on the speaker itself inside the cabinet, I'm going to put a little plug, 1/4 inch plug, that we can just always leave plugged in here. And if you decide you want to use 2 external cabs, as long as it equals the total ohms required, then you're good to go. Or you could just use one or the other, however you want to do it. All right, so I think this little panel is going to work good. It worked really well in my Gibson Skylark that I restored in one of the last videos I did. And I did something very similar, but the only difference here is that I will have high voltage on the diode switch. There is going to be a couple 100 volts here, almost 300 volts probably on the switch. And the switch is fine. It's rated to handle that. However, matter of fact, I might even put an even heavier duty switch instead of these little mini switches, but that's not the point. The point is you don't want to be able to put your fingers in the back of the amp and accidentally touch the back of this switch, right? Or any wiring around here. So I'm either going to fully insulate this so that you can't touch it, or put some kind of a back panel to fully enclose this so you can't touch anything and accidentally shock yourself. So just for safety, that'll be part of the design that'll be built in. But yeah, so that's essentially the plan, and I'll show you the parts here real quick. Give me a second. Okay, so here are the parts. So you have the boost cap here. That's all we need is a switch, and this is what the on-off switch looks like. And like I was saying, is you can buy these little mini switches on amp supply, sites and suppliers, but sometimes they'll charge you like $3 to $5 per switch, which is absolutely crazy. You can go on Amazon and buy like packs of 10 or 20 of these for $5, $6, something very much cheaper. So I prefer to get these types of mini switches on Amazon. Just make sure you're getting ones that are rated good, because there's lots of companies that make these, and some of them probably cut corners and are cheap. But I've never had any problems with these, as long as I don't overheat these pins when I'm soldering. If you overheat them too much, then you can melt the plastic and you can potentially ruin the switch mechanism. So you just have to be very careful when you're soldering these to not leave your soldering iron dwell on here for too long, or you could melt this and ruin it. Otherwise, yeah, they're very you know, they seem to be very hardy and hold up very well. So yeah, again, what happens is when you're looking at the switch this way, there's two lugs on this one. When it's in the down position, these two are not connected, right? It's like if you imagine an imaginary line like this, where that baton is, that switch baton, it's pointing up here. That's where it's engaged. So it's something is always going to be connected to the middle, but here there's no pin, so that means nothing's connected. When you switch it up, now this is connected to the middle, right? You see how that works? You can kind of see how the direction of the switch. So when we wire this in, when we want to do the up position, this is how we're going to connect it to our control panel. If we did it upside down, then the up position would be the on position, or these two connected, and up would be off, right? But I want it to be where these two get connected and put this into the circuit when it's switched up. So that might get a little tricky, but once we get in there, I'll show you exactly what it's doing. Here's one that is similar, but this is a, hopefully you can see it. Hold on. It's hard to get this to focus. On. So this can handle 6 amps, and then it's just got an AC rating, but I've used these for DC as well. They're fine for that too. Again, just as long as you don't put too much heat on them. So it's just 2 positions. When it's in the down position, this one is connected to the middle. When it's in the up position, this one is connected. See? Or if we accidentally installed it this way, this one would be connected now. This one would be connected like that, right? So these two. So we're just going to put this cap in, and the other side of the switch is going to go to the existing 0.01 cap, right? And the middle is going to go to the volume pot. Okay, so that's that one. And then this one, again, we have the bias stability cap. I'm just calling it that. It's to stabilize the bias, but we actually got a little bit of a volume boost when we put this in, and less volume dropping out as we're playing. It seemed to stay a lot more stable. So if we want that stability, that stiffness, a little bit extra stiffness, we're going to put this in and out of circle with an on-off switch. And lastly, these are, I have an on switch for this one. Again, it's going to be either tube rectifier on one side and diode on the other side. Here's 4 diodes. These are the standard sort of 1N 4007. They can do up to 1,000 volts. 1 amp, I think they're 1 amp at 1,000 volts, but these are usually what are used in most amplifiers that are under, the small amps like this, they're totally fine for. But they're going to do the rectifying of AC to DC. So the reason I have 4, we really only need 2, but I'm going to use 2 as backups. So in case one fails on one side of the transformer, then we have an extra one doing the work, and it's not going to, it's basically just a backup. These are so cheap that having a backup is so easy to do that's how I'm going to do it. And then the other 2 are going to go on the other side of the transformer. So again, the switch is going to go to the connection where the diodes are all going to kind of connect together. That's going to be one side, and the other side is going to be where the tube has rectified the AC and changed it to DC. And then this middle lug is going to go to our main B+ power supply, which is going to be where our first filter cap is connected, which we put a little terminal strip in there, so where that first cap is, we're going to connect it to that lug probably, right? And then here are the 2 switchcraft jacks. You can see the side with the side here, this lug here. You see how that there's all that metal. This is all part of the, hold on, sorry if there's a glare. This lug here is the ground side, and then this is the tip. This is where the signal goes through, and this is where the ground is. You always know that because when a cord goes through there, the outer shield, hang on. when a plug goes in here, this part here, this bigger part is the ground side, and that's touching all this around the base here. And then the top of this plug is the tip. That's where the signal goes through, right? So same with input jacks, output jacks, they both work the same way. In this case, the one side is ground, the one side is the signal. That's going to always be part of this, right? So I'm going to do 2 of those so that we have, wire those in so that we have speaker connections, up to 2 speaker connections, all right? Okay, and then how are we going to put this in? Well, I've got that already sort of planned out, and I did have to order something. So let me just show you that real quick. Let me just move this. Okay, so I put this panel on just to see how much space we have to work with. And I was originally planning on using something. It looks like the only thing this amp is missing that was original was there was a bottom panel. So here's the top panel. It's in great shape. I've just got it kind of anchored in there for the moment. And there was a bottom one as well. So essentially it covered up, and there was maybe this 4 or 5 inch gap here. This went all the way down. So I was going to use a piece of this stuff that I've used on a lot of like antique radios, and when I build amps in them, or if I'm just restoring an antique radio and it's missing the back part of it, but it had a backing. This stuff is great because it's really hard, it's really durable. It's kind of like a compressed board, and it's called hardboard, and I ordered this stuff on Amazon. It's mostly just used for like art supply stuff. You see this one here. This is a 11 by 14 panel, 1/8 inch, and I was going to use this piece. Problem is 1/8 inch isn't really thick enough for this. I mean, it would work. It would be fine. I could use this. But I found on Amazon some other art supply stuff, which is like MDF board, which is 1/4 inch, and that's exactly what this spacing is. It's 1/4 inch. So I think I'm going to go ahead and make a panel out of this MDF board, which is very similar material. Matter of fact, it might be even a little bit more durable than this. But since this panel's missing, I think one, it doesn't need to have the panel there. That's true. But it will change the sound. It will make the amp sound a little more bass. It'll have a little more bass response if you can cover this up a little bit on the end. That way the sound, yes, there's sound coming out of here, but the more you enclose a back of a speaker cabinet, the more bass response you're going to get out of it. It's going to feel a little bit more powerful, whereas this is going to feel more open, and frequencies are going to come, almost just as many frequencies are going to come out the back as it does the front, right? So if we enclose it a little bit, it's actually going to sound a little bit better. And the other thing too is that it's going to give me a little bit of extra material back here to anchor this new panel to. So what my plan is to, get the MDF board, which is going to be a little bit thicker. It's going to go all the way down to the bottom. There were 4 screws here, 1, 2, 3, and 4. So I'll drill holes for those. The power cord comes out in this corner, so I'll cut a little notch for that. Well, actually, I might not do that. I might just have it be coming out of the middle. But anyway, this will probably come up to here, and then this shows me exactly like how much room I have for this extra panel, and it'll give me something to anchor it to if I need to screw it into this extra MDF panel, which I probably am going to do. I think the way I'm going to do this, let me take this one off. I think what I'm going to do is probably take a piece of sheet metal and somehow like screw it to the existing chassis, or maybe bend it over and screw it in the top like this, and then bring it down and either screw it into the side here because there's this piece here, or possibly screw it to the back of this, or to the back of this. I'll have to see how it actually works out once I have the MDF board in here. So it's going to be a different thickness and whatnot, but it'll be a little bit thicker. It'll be like this thick, as thick as this piece. And I could Tolex it. I'll have to see. I don't think I have any Tolex that is exactly this style, but once I get the board, I'll see if it looks like it's something that the Tolex is going to stick to. It's probably very similar to something like this that's here already. But yeah, you can see they just wrapped it in Tolex, so I should be able to make almost a perfect replacement of what was there, minus having the exact Tolex style. But having that on the bottom here, like this, could give me something to possibly screw or attach that panel so that it's stable and it doesn't move around, right? I want to screw it to the chassis, anchor it either to the side and or to this bottom panel. And that's kind of like what I did with the Skylark in that video where I restored that one. Something very similar. I did screw it to the bottom panel and it stayed really nice and stable. And you know, you had your switches and potentiometers. This one's not going to have any potentiometers, although I could still add a tremolo intensity, but I don't think I'm going to, because I think that this tremolo sounds really good. It's not full intensity like the Skylark was. It's kind of like a 60 to 70% intensity all the time, and the louder you go with the amp, the less intense it seems. So it still stays very musical of an effect, even at louder volumes. So I don't really think that's necessary. And we won't have a whole lot of room to work with once for a control panel once I get the bottom piece on there, because it's probably going to come up to about here, because I'm just looking at those existing screw holes, so it'll probably be there. So that really isn't that much space. So something like this, it'll be enough room for a couple of mini switches and a couple of speaker jacks, which are going to get wired to these output transformer wires here, and then I'll make a little separate cord with a plug like this for this speaker that'll be plugged into that, and then that'll be our little enhancements panel. So all I need is a piece of sheet metal, make a couple of bends in it, drill a few holes for the parts, and then we can start wiring. The question right now I'm having is, should I do the rest of the restoration and then wire all that in? And that would include cleaning out this whole thing, removing all the dust, washing the Tolex, dusting out the speaker very carefully, taking that off. Like, there's still a lot of cleaning work that I'm going to do to make this thing look really, really nice and restored. But I was thinking maybe I'll just do all the wiring first. And as long as that little new panel is attached all the time to the chassis, which if I screw it in, then I can just take the whole chassis out and do all the cleaning and not have to worry about messing up anything else. So yeah, I'm not sure what I'm going to do next, but I just need to wait till I get that MDF board and then measure everything out and start building that little panel so that we can get that in there and start wiring stuff up. But I think these enhancements are going to be very easy to wire. It's going to be, a couple of components. Most of them are going to live up in here now, but we just need to run a couple wires to it. There is a little bit of space between here and the backboard. There's maybe like a quarter to a half an inch back here that I could run wires just straight down here. But I may actually make a tiny little round hole and put a grommet there just to funnel them all down into one nice, so that way they're not moving around and getting in the way of things and all that. And I'm putting it on this side because most everything is going to be done on this side of the amp. There's nothing over here. The wires would have to be much, much longer if I put it on this side of the amp, and would potentially introduce noise because we're running lots of long wires. Most of these wires aren't carrying signals, so actually, matter of fact, I don't think the only one that really is going to be this second one here, which is the swapping out that 0.01 cap to the volume pot with this one. That is carrying signal. So I may wind up using a shielded wire just to run this one, which will potentially cut out noise. I mean, the output transformer is very close to this panel, so this could induce noise with this component. I'm not really worried about it inducing noise with the rest of these guys. You know, the rest of these enhancements, because they're not really signal based, like the diodes and all that stuff. That's power. This bias cap over here is all power related. So yeah, there is one component that could potentially make this noisier by adding it, but if I use shielded wire just for that component, we could potentially cut down on all that noise, because the shielding will cut out any interference with other stuff like the output transformer, speaker jacks, things like that that could interfere with its signal. So yeah, the plan is solid, I think. It should be pretty easy to put together, and I'll show all of that so that you can see how I'm wiring it up. And if you want to do the same thing, if you have one of these, I can give you the diagram I have. If I wind up, I don't know if this is going to change by the end of the video, because I tend to do that sometimes. I'll think of a better way to do something, or maybe maybe one of these enhancements, I'll go, whoa, I never thought of this. Maybe I should do this instead of this. That could change by the end, I don't know, but whatever winds up, the end result winds up being, if you want that diagram, I can send it to you. So just write me in the comments or something, and I'll get it to you if you want to do this to your Kalamazoo. Or if you want to build a clone of a Kalamazoo from, you know, your schematic or whatever, and you want to make these enhancements to it, you know, it's pretty easy to do, so I can totally send you what I have. All right, let's get to the next piece. Okay, we have some material here, some brand new material. I just cut this piece of MDF board. This is that 1/4 inch stuff that I mentioned I ordered. So yeah, this was just something on Amazon. I've never ordered this particular type before. I mean, I've worked with MDF board, but usually it's kind of bigger, thicker stuff. But this stuff's great. I mean, this was like a pack of, I think, 8 boards, maybe 11 by 14, I want to say, or I don't remember. I can't read it on here. It kind of got smudged off, but it was an 8-pack. Yeah, I think it was 11 by 14 pieces. So I easily cut a piece. But what's cool about this is it's very similar durability, and you know, they're using some kind of compressed board, but you know, this stuff is, I could break this, you know, I could bend this and snap it if I put enough pressure on it, but overall it's pretty durable, right? So this is the top piece. Actually, let me take this off. I'll put that on there in a second. So I just cut a piece out of the board, MDF board here, for the bottom panel, which is missing, and I can see these 4 screw holes. So basically what you're gonna get is something like this, and I think I am gonna actually Tolex this. Why not, right? Let's do it right. If we're restoring this thing, again, I don't even know if you can even get this exact pattern of Tolex. It's a really unique pattern. It's like almost like stippling, or stippling. I'm not sure how you say that, but you know, it looks like little holes were put into it. I don't know if you're gonna see that here, if it's gonna focus right. It's not like it almost looks like the typical Bronco style Tolex, but it's not. You know, when you look at it if you look at it close up, it's definitely different. It definitely has little kind of holes punched into it. And it's a very fine pattern, not like an elephant skin sort of a pattern. So anyway, long story, I found a piece of Tolex from some that I ordered that I believe is close to like a Sun Model T design. And it's kind of about that same, very similar texture, but it's a little different because this has kind of got some cross sort of, you know, hatch sort of patterns, but it does have almost those little dots in there. It's as close as I could get, right? I've never seen any stuff. I've ordered a lot of Tolex over the years, and I've never seen anything that looks just like this. So, you know, 1960s. Maybe somebody knows where to get some, but I'm not that worried about it. And also, it's gonna probably match up even a little better once I wash this Tolex and put some coating on it, because I have some Tolex cleaner that really shines this up and makes it look new, and it'll make it shiny like this stuff. So while the color might not match exactly, because this is almost like a charcoal black, whereas this is like a almost like a midnight black, but it has that sheen to it. Anyway, I'm gonna Tolex that. I don't know if I'm gonna film that part or not yet. It won't take long because it's just a small piece, but I cut this piece, and essentially I'm just gonna take this panel and trim it up just a little bit and stick it to this and fold the edges over, you know, like so basically. And then we have a panel that fits and looks pretty good, you know, maybe not exact as the original, but better than not having the panel. And I think that's also going to make the sound a little bit more like the original, so not all the sound is coming out. Alright, so I also did one other thing. The control panel, I've already sort of fabricated this out of a piece of thin aluminum. It's not super thin, it is pretty durable, but basically what I did was it's crude, it's not perfect, I'm sure, but it'll work for what we're trying to do. So I just folded over the top, folded the edges to make like this C shape, and then I marked based on that design that we had, where this is just a sticker, so this is bigger than, well, actually let's do it like this. So what I want to try to do is something like this. The panel will get screwed onto the chassis here. Okay, I'm just going to leave it set there for a second. It's about 3.5 inches is what I made the panel, and like 1/2 inches on the sides that fold over. Something like this. It's hard to get it to stay right now because it's kind of like hanging off of there. But the idea is that I'll have a little bit of room for a logo, hopefully, just so that, you know, if somebody buys this in the future, I sell this or something, they'll know who did these mods if they have questions or anything. And then 2, we'll have 4 spots for our switches, which are going to go here, so I just need to drill some holes there, and then 2 spots for our output jacks, and hopefully enough room that we can at least put some sort of labeling on there. And also what I'm going to do is very similar to the way I just recently restored that Gibson Skylark. I'm going to put some sticker vinyl over top of it just to make it look nice. Instead of having to go through the process of painting it, the vinyl looks great. It gives it a nice professional look. So I'll probably drill the holes, put the vinyl on, cut the holes out, install the parts, and then we can just print out some vinyl lettering to stick onto here. That's just a pretty easy DIY way of doing it without spending a lot of money trying to send off some custom control panel. Now if I was making 20 of these things, sure, maybe I'd look into getting some kind of a laser etched control panel made or something like that, but I'm just doing a one-off here, so that this will work for that. So yeah, that's the plan. It looks like it's going to fit really well. I think, in case any of you guys have a Kalamazoo 2 and you need to know the dimensions, it's very simple. I think I did 7 inches total even with this bend by 4.5 this way, and then I just did 1/2 inch bends like that. So it's crude, but hey, it works. So yeah, I'm gonna do 2 holes on the top to mount screws so that it'll hold on to this chassis, and I haven't decided if I'm going to put a screw in the side. It's going to be a little hard to get to, but I think with a long enough screwdriver I could either mount it and screw it to this side, or maybe screw it to this panel somehow. I wanted to do it so you didn't see any screws in this panel, but it's so thin here that I don't know, I might have to do that. I may have to put a bolt through it and a nut on the other side, so that it stays secure. So alright, we'll figure that out when I get to that. I got a little bit more work here to do on the control panel, but yeah, and also want to throw some Tolex on that panel there. So yeah, I think we're in good shape. The plan is coming together. So once I get to that, then we can get that part done. We can do the wiring. I'm just trying to decide, should I do the full Tolex cleaning somewhere between doing all the rest of the wiring, or should I do all the wiring, then take this all out, and then clean everything that's there, all the existing stuff, the speaker, the insides, because I like to scrub things out with soap and put some Tolex cleaner on here and preservative, basically a protectant, kind of almost like an Armor All, so to speak. But it really does a nice job of shining up the Tolex and making it look almost brand new. So yeah, just little odds and ends. These little hanging threads I can cut off. I'm just going to make it look as new as I can. So, all right, I'll skip to the next part here. You guys can check it out, but I'll go ahead and drill these holes out and try to get at least the cover on, and then I'll come back probably and we'll do the installation part together maybe. Okay, I have set this up for Tolexing. Hopefully you saw the previous time lapse of assembling the control panel. I think it turned out really good. Here it is here, if I can get it out. I don't have it fully installed yet, but yeah, I think it turned out really good. We got our 4 switches. There's a lot of space up here, but that's because part of that upper panel is going to cover that, and we need space for labeling and whatnot in our speaker jacks. So really good there. We're going to mount that soon, but I thought, let me just knock this out real quick, at least get this that way by 24 hours from now. Actually, not even that long. This thing will be fully set and we can kind of screw it in there and see what we're working with. So yeah, I basically have some craft paper that you can get from anywhere really. I probably got this stuff from Ace Hardware or something, a roll of it, but I've used this over and over again, and I've Tolexed a lot of boxes. Not as many flat panels like this where it's just one little piece, but in theory this should be a lot easier. I just need to, and what I could technically do is that we could technically just staple this if we wanted. We don't even have to really do that. But I'd rather do it the right way, because that way it won't hopefully kind of bubble up. It can get really tricky stapling things. And also it can kind of loosen this piece of MDF board. Like if you get a staple too close to the edge, it might start to erode some of the, you know, and break down some of the sides. So let's just throw some glue on there. So I've got, this is Tolex glue. There's no label on it, but I got this from a amp, you know, and guitar parts supplier, probably amplifiedparts.com. I can't remember where, but I've used almost this whole bottle, and knock on wood, this is the best stuff I've used so far. I've used a lot of different kinds of adhesives for Tolex, but this stuff just does a good job. It's low fumes. I don't even hardly smell it at all. So I can do it indoors. I don't have to worry about ventilation. It's non-toxic as far as I know. I believe it's just like a what's that, latex. It's like a latex based glue, you know, so it's stuff that you would put on your skin if you were in a horror movie to attach the, you know, the mask material and stuff, right, on your face. So it's very similar to something like that. But it is very sturdy, and it holds up really well, even in high heat situations. I used to use some other glues that would definitely not stay as sticky over time. There's a little gnat in here. I'm gonna get that sucker. The only problem is now I can't get the lid off, so give me a second. I'm going to heat this up with a hairdryer. I had a feeling this might get a little stuck. Sorry about the noise. Hopefully that did it. Yep. Usually just a little heat will open these things. See how that's real stringy? That's that latex. It's like a rubber almost. But yeah, it's got real sticky here. So what you want to do if you use this stuff, I prefer to use a cheap throwaway brush. We're not going to even try to clean this. I got these on Amazon for probably, you know, a pack of 10 for a few bucks. That's all you need. Just something to apply it. And you got to be pretty quick with this stuff. If I'm doing a full-on amp case, I may go through several of these brushes, because once it starts to get really clumpy in here, like it was here that I just peeled off, then it just starts to get really tough to apply anymore. So I've shaken this up really good. I've just got a simple paper plate and this craft paper just to cover my workspace for now. And I'm just going to set this in here for a minute while I mark this. This should be pretty simple. Alright, so I'm just going to try to center it best I can. It doesn't have to be perfect. And the reason I'm marking this is because I want to do the main panel, and then I'll do the wraparound parts, the edges parts, after the main part of it is stuck. So I just need a guideline, essentially, like where is, and I also want to make sure that I stick it fairly close to where I just marked it. Okay, so hopefully you can see there's a little pencil line there, and we're gonna first, actually, go ahead and just use this side. I need to put something here that's gonna stay, something heavy. That should work. Okay, because what I'm gonna need to do here is, and I'm just gonna, sorry if this is a little out of frame at all, because I'm trying to give you two different angles here so you can see what I'm doing. Don't need a ton of space to work with this, but you just want to apply it on there and make sure it really kind of gets in all those little grooves. Obviously this is the back side of the Tolex, and you can go over that first line I made, those guidelines. I'm going slightly over that. That's totally fine. I just don't want to do the entire piece just yet, because it'll be easier to work in sections and it'll be more effective and stick better. Now as I'm applying this, I'm seeing some little holes, like air holes popping up. That's why I want to make sure that I get a pretty even coating and go back over it a couple times. And it doesn't take a lot. I mean, I've probably done, and these weren't large amps, these were like medium size to smaller amps, but I've probably done like at least 4 or 5 different amp head cases with that one bottle of glue. If they were larger, like 100-watt amp size, probably could do 2 or 3 amps, depending on, you know, how much is actually being Tolexed. Like, does it have a grill in the front that you don't need to Tolex? That'll be less glue, and so on. Alright, so what I want to do is, we don't want to stick it yet. We want to do both sides of the surfaces that we're trying to get. So I'm going to let this sit. We want this stuff to set up and get tacky. So I need to do this MDF board like this. And I think this one, because it's a flat surface without a lot of grooves in it, is probably going to dry quicker. But it's going to get tacky, and we can speed up that process by using a heat gun or a hair dryer. Today I'm just going to be using a hair dryer, because I do have a heat gun, but the hair dryer was technically closer to where I'm working, so I was like, you know what, that'll work. It doesn't need to be super hot air or anything. Maybe just slightly warm will help to speed it up. It could even be cold air, you know, it could be a fan. But if you don't want to wait for this stuff to really set and start getting really tacky, then you can speed it up by blowing air across it. So I'm not worried about any stuff getting down around the corners and sides just now. If a little bit does, that's totally fine. But I just want to make sure that it's covering all the surface. Pretty simple. Yeah, it doesn't look like the MDF board is going to soak much of this in. Just a tiny bit more over here. Over here, maybe. If it's thicker in certain areas, it's just going to take those areas longer to dry, so it's kind of hard for me to get it perfectly even, but that's fine. It doesn't matter. It's going to be okay. And this looks like a pretty good covered application here. I don't think I need to do any more here. All right, so what I'm going to do now is go ahead and dry these with the hair dryer to speed up this process, so I don't have to wait. Otherwise, I'd probably have to wait about, it depends on the environment, how cold it is or warm it is or how humid it is. It could take 10 minutes, 15 minutes for that to really set up. If you put it on while it's wet like this, chances are it's not going to bond well. If this side gets tacky and this side gets tacky and you push them together, it's going to turn into that stretchy glue, and both sides are going to be stuck with this really stretchy glue, and over time it's going to get harder and harder and stick together. So that's what you want. You want it to get really tacky and not be wet anymore. So I should be able to touch my finger to it and not get wetness on my hand. So bear with me. Hopefully the noise won't be too bad, but I'm going to put the heat on low. Actually, maybe I'll just put it on medium. I don't think this is going to get too hot. And high fan for this hair dryer. that's probably it. That's probably all it needs. I think that was like less than a minute because I noticed that when I touched my finger to here, it's not wet. It's starting to come off and see. I don't know if you could see that, but it's starting to crumble and get like it pulls. So that's sticky enough, and you see how clear it's getting over here. So this stuff's really drying fast. So this should be fine. We can stick it now. Just as long as it's not like coming off in like really wet patches. Alright, so what I'm going to do here is just try to get this lined up best I can. I can't see my lines anymore, but I'm just going to get it as close as I can. Might not be perfect, and that's okay. Go ahead and push that, and then I have a little roller to really apply some pressure here. And most of the time you don't even need to worry about air bubbles or anything. I mean, this stuff will, once it's stuck on there, man, it's good. Now, before, it's obviously going to take it some time, maybe a day, to fully cure, right? So if I have to make an adjustment, I could pull this off now. It would take a little bit of effort. It's pulling, but I can see it like starting to stretch, right? So that's what you want. You want it to be like stretchy. And there we go, there's that side. Now what we'll have to do, since there's corners, and when we bend this over, we're going to have this extra piece here. So we're going to have to either cut that off completely or cut a diagonal. I'm going to try doing it with cutting a diagonal. So basically what I'll do is all four corners, small straight edge, and do something like from the corner of the board to the corner of the piece. I don't know exactly how this is going to work, but because I didn't make this perfectly square, or there's like one side might have more space than the other side, more material than the other side, right? So I don't know how this is going to work, but I'm just going to go with that theory. Either way, it's going to be fine because it's going to be wrapped around to the side that nobody's going to see. But since I just did this and cut this piece really quick and didn't worry about absolute perfection, then we're just going to see if this theory works. I think it's going to be fine. Yeah. Alright, so I'm just going from a corner, 45-degree angle, to the corner of the material. See that? Which just kind of releases that. Like that. Right, so essentially what we got is this, and then we can chop off. I'm just gonna pull this over and stretch. I'm just giving it, I've never done it exactly like this on a little panel, but I'm just trying this. I'm gonna try something new, slightly new. In theory this should work. So I just cut this little excess piece off there. Cut this little corner off here. Maybe your people that do these panels all the time be like, nah, you should have cut it as a square instead of a triangle shape, because then it would be easier. Maybe you're right. I don't know. I'm just trying this out to see. Probably should have, because yeah, if I'm cutting this excess off, yeah, I didn't need to do it that way. I should have just cut a square. Oh well, you live, you learn, right? So, but this is fine as long as it comes over, wraps over. And then I'm going to go ahead and do it like this and have these longer ends wrap over that part. And I can always put a staple on that if it needs extra support. So for now, just cut that. Cut this. So just cutting these. I probably should have done this as a square. No problem though. This will work. When I'm doing a box, I always have to do these 45-degree angle cuts for the corners of the boxes. And they come together perfectly usually if you get the angle right. But this is a little different because I know it is a three-dimensional shape, but it's almost like two-dimensional because it's so thin. and we don't need to worry about what people see on this side of it. So, all right, that should do it. All right, so now I think I'll do these ends first, these smaller ends. Okay. I'm gonna go ahead and just put a piece of paper towel down so that I'm just protecting my paper so I can reuse that over again. And yeah, see, this brush is already starting to get hard. It doesn't take long for this stuff to set up in the brush, so I have to pour some more. If you keep the brush in the wet liquid, it'll last longer from getting too hardened up. So all I'm trying to do here is just coat the board, the material, and the board, the edge of the board right here, and about a ½ inch or so in. See that? Just right where that material is going to go. I probably should just do one side at a time, but I was gonna do, yeah, let me just do one side at a time, see how this works first. It's just to be sure. I think that fan speed was too high. It's blowing it everywhere. This MDF stuff is drying a lot faster than the Tolex is, and there's a lot of excess wet Tolex here that got down into the corner, so I'm gonna pull some of that up because that stuff's gonna stay wet and might not make a good bond. All right, a few more seconds on the air. I turned it down to a low speed and just it's on medium heat right now, or low. I was switching it between low and medium. It doesn't need to be really hot. Don't do it too hot. Should be good enough. All right, so I'm just gonna kind of take it here. I can feel it's tacky now, and pull it really nice and tight like this, and just stick it. Now any glue that gets on there, I've got some stuff that'll take that excess glue off. But yeah, that's stuck really well. That's stuck really well. Just a little bit of pressure from the roller. I think that's gonna be fine. Alright, let's do the other side. I'm just going to try to barrel through this really quickly. You can obviously skip forward if you don't want to see this part. It's just rinse and repeat at this point. I'll keep going with the camera for a moment. Maybe I'll cut out the last panel or something, or the last side, and just finish it so you don't have to see it. But you can just see what I'm doing, the process. And then when I'm done, see, these are going to go over, and I may just trim up the edges if there's a little overhang, but otherwise I think this is going to be good to go. And then probably going to let it set and then drill the holes. I'm going to see if I can match them up exactly to where the holes are on the actual cabinet, because there are those 4 screw holes. So I'm going to see if I can mark them, measure them, and get them so that they match up with those existing holes. It'll just be easier to replace it like that. So, all right, so now that I've got this side done, I'm gonna go ahead and scoop up some of that little excess that I got in those corners that kind of fell into that corner. It's still really wet. It's just not a pool of stuff. All right, let's hit this for about another 30 seconds. definitely tacky. All right, I'm pulling up nice and firm and pushing it down as I'm pulling this way to get it on there tight. That's the easiest way, I think. Make sure there's no like bubbles on the ends. Yeah, that worked really well. See, I had a little less glue that time, so it didn't get quite as messy as the other side did. All right, so that's how we're looking so far. And yeah, there's a little glue here and all that. We're gonna clean all that off. No worries there. I got some stuff that'll get that off. Actually, even some rubbing alcohol, maybe after I'm done here when it hasn't fully set yet, that might do it too. Already getting all this. See how this is starting to dry on my fingers and kind of ball up into like a latex ball, like almost like a booger sort of a texture, like sticky. But yeah, I need to keep my brush in the wet stuff so it's not gonna harden up on me yet. Okay, let's do, speed it up, Mike, speed it up. Hold on. Just want to cover, make sure this is covered. Then I can reuse this paper. Get it all the way into the side of the MDF board, really good, all the way out to the edges. And you know, as I'm working with this, I can't even smell it. Like, unless I put my nose to it, I can't even tell that there's any smell at all. And it dries so quickly that, you know, I'm not saying that it's 1,000% safe. I really don't know if it's. I mean, I'm pretty sure they're using fairly non-toxic stuff. I mean, I've used some adhesives that had some extremely strong fumes that did make me feel sick before, even using them outside. If it's not a very breezy day and you're breathing some of that stuff in, it's no good. Especially any of the spray adhesives. I used to use the 3M sprays, some of them, and while they seem to work really well, they don't seem to hold up over time as well as this stuff does. They work really well in the beginning, and then, you know, they just start to, I think, like if you have a big array of tubes in your amp and there's Tolex that's fairly close within a couple of inches of those tubes, and those tubes are getting really hot, the 3M sprays tend to, like the Tolex tends to peel up. And I didn't know that when I first started using Tolexing boxes. So I've had to repair some amps for some friends. I made them amps, and I've had to repair some Tolex. And if I use this stuff, I can guarantee it's going to stay on there. I mean, once it's cured, it's not coming out. Notice how I put a little bit on this part of the Tolex here, because I'm just going to wrap this over it. You see how I did that? Just right here. It's probably too much now. But I want it to stick to that side of the Tolex as a wraparound. Okay. Quick minute here, half a minute, whatever it takes. Okay, that one took a little bit longer just because I think I slapped it on this Tolex a little bit thicker this time. So yeah, I'm just going to use my hand to sort of pull this forward. That seems to be working pretty well. Just pushing it on there. Okay, just give it a little pressure. I mean, it's feeling very nice and secure. So I think by morning, that stuff's gonna be on there. But yeah, that looks great. I'm just gonna trim up the edges a little tiny bit with a X-Acto. But yeah, man, one more side. Let's get it done. Okay, this one. Make sure I get in that corner really well. Yeah, this brush is starting to get, just because of the time I've had it sitting out and it's been wet with this stuff, the brush is getting really, I don't know if you can see, where's my other camera? It's starting to get a little kind of bunched up at the edges, and that's the whatever it's called, latex is starting to dry up and kind of clump. But not a big deal, as long as I can still apply it. It's just, if I was doing a big amp, I'd probably be already changing brushes by now, if I had a big case. That's why getting the cheap throwaway ones. Now, I've tried some other ones. I've tried some ones that aren't brushes, that are actually like, they're like a silicone sort of a applicator. But I do not like them. I could not, it just felt like it was really hard to work with, and a lot of people say those are good for this kind of glue. I'll show you what I mean in a minute. I think I have one sitting across from me. I just couldn't, I tried it and I just couldn't get it. It just didn't feel like I was spreading it right. That's why I went back to these cheap brushes. I was hoping that would have been a great thing, because then I don't have to worry about cleaning so much stuff. Let's see if I can find it. Yeah, like this thing. This is what I'm talking about. So this is supposed to be an applicator for this latex. See how that's peeling like that? So it's really easy to clean these, because you could just peel off the stuff from the time before you did it. Really easy. And it's silicone, but to apply stuff with it, it was just impossible. It seemed impossible to me, especially getting in these little corners and stuff. I don't know. I was having a really tough time using it. I was hoping that'd be good, because then I'd be like, well, then I don't have to keep buying these stupid throwaway ones. I feel like it's a waste. Even though it's very cheap, it's still a waste of materials to have to throw these out every time. But I've tried cleaning them, and it's just like impossible. So, alright, one more. Let's get it heated up. Get some air on it. Feels like it's setting a lot quicker. Well, maybe just a hair, a little wet. telling you, if you do this and you use this stuff, take your time and let it set, let it get tacky. It'll make a huge difference. If you try to apply both sides while they're still really, really wet, they will not make a good bond. So it's worth it. Once they get tacky, then they start to really stick together. So last one here, just pushing, pulling upward. There we go. Okay. Some pressure on that whole thing. I'm gonna roll this one more time. Roll these edges a little bit. Yeah, we just got a little bit of this latex to clean up off of there, but I might wait until tomorrow to do that. Just because if you use some of that, what's it called? Goo Gone. It's like an orange oil. I'll show you. I'll show you just because I don't think I'm going to put that part on this video, but see this Goo Gone, this goo and adhesive remover? This is a spray gel. And it's basically just an orange oil. It's like a citrus orange oil. And just a little dab of this on a cloth will completely remove this kind of glue. And a lot of other kinds of glue too. And it just works really, really well for stuff like that. Old remnants of where a sticker was on your guitar, or just don't use too much of it. It doesn't take a lot. Like I said, I just use like a dab of it on a microfiber cloth or something, and that's all it takes, and just kind of swirl it around and work it out, and then all that stuff will come off. Especially this stuff comes off super easy with that. I don't know if it's the acid and the citric acid in the in there or what, but all right. I feel like there's just a tiny bit here. There we go. There's our panel. Clean it up, and I think it's gonna look good. I'm just gonna kind of retrofit it in there real quick and call it a night. Come back and we can start wiring stuff up. Or start cleaning up the cabinet and then wiring stuff up. I haven't decided what I'm going to do yet. But yeah, let me bring that over real quick. I can get this cleaned up, and I'll show you. Hold on, I'll be right back. Okie dokie. Here we go. Let's see how this works. Now, I didn't make this panel super... I gave it a little bit of less space so that the Tolex would have a little bit of room. You know what I mean? Like when I measured the size, I didn't measure it to fit like perfectly in there. I gave it a little extra shortness, so because I knew that Tolex had a little bit of thickness too, and it looks like that's going to work perfect. Yeah, once it gets screwed in there, perfect. Now I'm not going to leave it in there like that tonight. Now, yeah, you can see it does look a little different. I think it's going to look a little different permanently, yes, but once I get this part of it cleaned and shined up, it'll look a little better. It'll look a little more like it belongs. It's not going to be perfect. Again, if I knew somebody that was selling this old Kalamazoo stuff, Tolex they used for that, I've never seen this style on anything else before. Not even on the old Gibsons. They used a different... this was made by Gibson, obviously, but this line of amps, it's like maybe they had some custom material made for them for that, or said give us a roll of the cheap stuff or whatever, or stuff you don't normally sell, and they used it on this. Who knows what they said? I don't know. But yeah, this is going to work great. So let's just see what it looks like real quick with this panel in there. Let's see if I we're just kind of mock putting it in there, so it's not perfect, but yeah, that'll be nice, I think. I don't know if it's quite on there perfectly, but yeah, you can sort of see once it's screwed in to place. I think that's going to work really well. All right, I can't wait to get to the wiring. That's my favorite part. Wiring and testing and playing it. But yeah, I think we've got one good thing accomplished. On to the next phase. Thanks for sticking in there if you watched all of that. I know I can be boring, the Tolexing, but it's really not that difficult if you use the right materials. Okay, it's the next day, and this thing had set up great overnight. I checked it, and everything's sticking very well with the Tolex, and I also drilled the holes and put some screws in. Unfortunately, I don't have any of those countersink screws, the ones that have the head shape like this. I looked around. I don't have anything quite like that, so I do have these flat pan head screws that are wood screws, so they'll work. I mean, they're the same color basically. So, but anyway, yeah, this thing worked out really well. I just need to clean it off. It's still got some of the glue on it, but that's easy with this Goo Gone stuff. Take this out, and also this is just the panel here. I'm about to mount that and start on the next section, which is actually wiring up these enhancements. So this is kind of a little precursor of what everything's going to look like. Just set this up here. Once it gets mounted to the chassis, again, I think my best method of attack here for stability of this new panel is it'll be stable once it's screwed in with 2 screws to the chassis, but then to keep it from flopping around down here, I'm probably going to have to, I think I'm going to have to, since this is so thin, drill a hole through this and through the panel, like all the way through, to have like a bolt on the back of it. So not a big deal, it'll have a little screw here, but this isn't the original panel, so I'm not worried about screwing up something that's not original, right? I mean, not screwing it up, but the only other way to do it would be to screw in and anchor something to the side here. One, that's probably not going to be as stable because it still might be able to kind of flip a little bit like this. And two, it'd be really hard to get back there. If I have a bolt just in the center here, I should be able to just reach my finger back there and screw on a little bolt on the back of a, you know, something like that. That should be pretty easy. So that's the plan, and that's what it's going to look like. So let me get this thing taken apart. Let's get this circuit out here. Let's get this attached so that we can start making the enhancements. I think that's the part everybody's hopefully excited to see. How do we wire this up? And we have a diagram to follow, partial diagram anyway, and then once we get to the actual wiring of it, we'll see how we're going to do it inside here. So I'll show all of that. Drum roll, please. That was a terrible drum roll, but I'm not a drummer, so let's get to the best part, the funnest part, wiring up this enhancements panel. We're finally here. I know it's a long video, but it's sort of a teaching video, so hopefully you're getting something out of this. But let's get to it. Let's do the fun stuff. Okay, I've got the panel attached. I didn't show that, but basically just following my plan. I got 2 screws on the top here that are screwed to the chassis. So I'll take you around this view, and then I'll kind of get rid of this view in a minute. But you can see I had to prop this up on a much higher stand here because this is here. I could angle it down and put it on the flat surface, but then it would be on an angle. I thought this would be easier for you to see what's happening by propping it up though. So yeah, I mean, it's pretty stable as is, but I think I still am going to put a hole here to mount this panel to the actual cabinet once it's in there. So that way if you need to do service on it, you just take out the one bolt You take out these 4 chassis bolts that were original, and you pull the whole thing out with this panel. And if you ever need to reverse any of this stuff, disconnect the wires and the components that we're going to add, disconnect these 2 screws, and you pull it off. It's done. Back to a totally original. Well, aside from what we did here with the filter caps, because remember, this big old can cap was in there just kind of bobbing around in there. So we have a much more stable way of doing the caps, easier to change, cheaper to change than a can cap. It should be cheaper anyway, I guess, unless the price of these go up or something over the years. This is 2026, so who knows what the price of all this stuff's going to be in another 5 or 10 years if you're watching this way into the future, if we still have a future. All right, so let's get to it. I showed you what that looks like. Let me get rid of this camera. So now we have a full sort of bench view of what we're doing. I think the first thing I'm going to do, there are a couple things I want to shore up in this circuit, and I'll tell you what that is in a minute. I have to remember what they are. One of them is I want to put some insulation over the leads of this cap in case it moves. But yeah, I'll do that in a second. What I want to try to do real quick though is, first thing I can actually connect to this panel. Just give me a second. I'm going to need to get rid of this stand because I got to flip it over. First thing is I can connect the output transformer to the output jacks, and hopefully this view, yeah, I think you can see that. Pretty easy to see. So we have these 2 leads, right, from our output transformer. These were going directly to the speaker, the internal speaker. But now we're going to have an opportunity to not only unplug that speaker with a little plug, right, and plug it into this jack, but we can also unplug it and connect an external speaker and or 2 external speakers. Let's say you had 2 like 12-inch 16 ohm speakers, like maybe you have a, you know, I like to use those old Bell and Howell or a Victor speaker cabinets that were made for video projectors back in the day. They have really good 12-inch Jensen speakers in them, and I like to use those sometimes for little amps like this so that I can run a 12-inch speaker, because I think the speaker that's in this is a 10-inch. But anyway, if I wanted to do that, and as long as I'm matching the ohms to 8 ohms total, then I can do that by just unplugging these jacks. So the wire on the output transformer isn't super long. I guess I'll go this way since this is the shortest route. But what I want to do is I just need to connect these to one of the jacks. Okay. And yeah, actually it looks like we have just enough here. As a matter of fact, I think I'm going to go ahead and trim the ends of this just to start with a fresh piece, because it does have old solder on it. So just give me 1 second to move this around, and I'm just going to use my desoldering gun, this, to solder for the moment, because there are a couple things I might need to unsolder, so I'm just going to use that for right now instead of my regular iron. It'll do the same work, same thing. Alright, so I need this one to stay pretty long. I'm just going to cut the ends off of this. This looks like it might be the exact length I need to. I'm just going to cut these little ends because they've been soldered and unsoldered many times. Just when I think I've got all my tools out to do something new, there's always something else I didn't think of. So, wire stripper. This looks like solid core. Yeah, this might be solid core. Okay, that's cool. So I just need to strip a little bit. Yeah. I don't know if it looks solid core. It almost looks like it's stranded, but it's not fraying out. So that's cool. So yeah, I'm just going to take this and connect it to, this is the positive, this is, and if you don't know, if you're working with these jacks and you're not sure what's what, here's what you can do. You can take your meter, multimeter, put it on continuity mode, which is the beep mode, right? That means if there's connection between these two leads, it's going to beep, right? So if I touch this part of the metal here and I touch this part, that's continuity. That whole piece of metal is one piece, right? So if I want to see where the tip is, which is this, which is what's going to drive this, send the signal out to a speaker, I can touch one of these tabs with one and touch it with the other. So this is the tab that's connected to this. If I go over here, that's not connected. See that? There's no continuity between this tip part and that lug. That's the ground lug. This is the signal lug, because the signal is always going to be the part of the cable that connects. Let me grab a cable. See, this is what I'm talking about. This part carries the signal. This longer part is the ground part. So when we have a cord in there, that's the part that touches this little piece. You can see no continuity there, but there is continuity here. If I touch the longer part of the shaft here, there's no continuity between that and the tip, and also there's continuity here on the ground lug. So just in case you don't know which lug is which, you can use your meter to verify. And once you've done this many times, you'll know which is which just by looking at it. But I just wanted to show you in case you weren't sure, which one do I connect it to? How do you know? They're not numbered or labeled or anything, but one is always going to be the ground and the other is going to be the, on these two lug switches, two lug switchcraft jacks. Alright, so I just need to just bending that wire over there, and then I'm gonna put the ground wire in here and bend him over too, so that we get a nice mechanical connection, right? I'm just gonna crimp it on there with these pliers just so it's nice and secure. And before I solder it, I'm gonna go ahead and wire this other jack. So basically all I need to do is connect the ground to ground and the signal to signal, and then we can send that same single signal of guitar out to one cab and also out to another cab. So we're just doing these two jacks in parallel. Okay, so I'm just going to cut a piece of wire. This is just solid core vintage style pushback wire, which is great because I don't have to strip it, and it's a pure solid piece of metal. It's what I prefer to use on a lot of amp stuff. It's easy and quick to work with. It's maybe a little more expensive than some of the stranded wire, but I don't have to strip things, and it's just a preference. Both do the same job. Although I think Alexander Dumble, the guy that did the Dumble amps, I think he was dead set on solid core wire carrying the signal better than stranded. At least I read that somewhere. I don't know if that's true or not, but I don't see why it would make any difference unless you had really cheap stranded wire. All right, so I have one end of the ground. I'm not even going to put any flux on this right now because I don't think I'm going to need any. I'm going to heat up the lug with both wires in it, and I'm going to let that solder flow to the iron, because this solder does have flux in it, some flux in it, and that's probably enough for this jack. Okay, that's good and secure. And then I'm going to run that to ground here. Just trying to make it nice and neat. Let me put my microphone a little closer. Sorry if the volume goes a little quiet and loud. I'm trying to use a mic to get a little better quality of voice, but distance on this does matter, so I need to remember to stay close to it. Alright. Here we go. So that's the ground on that side. I'm gonna bend it over. Actually, it only really needs to be bent once. I don't need to go nuts with this. Trim off a little excess. Heat up the whole lug. Actually, I'm going to do it like this. Hopefully you'll be able to see. There we go. Make sure you give it a good amount of heat. And then once that sets, always check. Give it a little tug. Make sure it's in there good. Just give it a little pull. Make sure that's good. Make sure this is good. Yeah. Alright. And you can always straighten these up later if you want to. This is what I like about the solid core too, is that when you put it into a position, it'll stay that way. You can get the wires really nice and straight. And let me see if I have any green. Not that I have to use green, but we'll match color just so that if somebody sees it, looks like we did a nice job. So okay, then we go signal, put a little bend in this guy, and I'm gonna kind of crimp it over just same way I did here with the black. Heat up the lug with the wires. I'm just going to set this up here for a minute. Come at it from this side and let it flow to the heat. And you don't want to dwell that too much on that side, because these rubber wires, you can see it did soften this wire just a little bit here. The heat will soften those. These guys can take a lot of heat, these solid core, because it's just got like a cloth cover that won't, it would take a lot to melt it. And then trim it to size. We're almost done here. Push it back. Angle that in. Make a bend. Get this one soldered. Okay, trim off any excess just for cleanliness. That one. That one. That one. Here we go. Now we got our speaker jacks wired. Easy as that. That's an easy one, right? Actually, most of these are going to be pretty easy anyway, these enhancements. They're nothing majorly complex with wiring, but I do want to make sure that it's clean and, you know, it makes sense to somebody that may look at this and service this amp. So this is what I'm trying to make everything nice and aligned properly and clean and so on. So yeah, that's good. So our output transformer is now connected to our jacks. If you wanted to check continuity, you could pop this in, pop one of these cords in, and put it on continuity mode. Again, if this touches this, it's going to beep. I'm going to connect one end of here to just the tip, right? And I should be able to touch this tip and that tip, and they should have continuity. And I should not have continuity to the grounds, which is this. Sorry, I touched the tip part. Hold on. Yep. And oh, it's hard to get out of there. Both of these, same thing. All right, so anyway, long story. There's not much there. Don't need to really test any further, but that's all connected, and we have jacks now. So let's go ahead and flip it over, and that looks pretty nice too. I think this will stay in place. One thing I might wind up doing is creating some kind of a cover, at least for down to here, because we are going to have some high voltage on this, at least this switch. And I don't want anybody to accidentally reach back here and touch anything and shock themselves if something's turned on while you're reaching into the back of the amp. Like, what if somebody had to check a tube and somehow their finger brushed against this? That would not be good. I also drilled one other hole in the chassis. Yeah, I had to kind of do this. I needed a way to route the wires, and I found that this area right here, I put a little rubber grommet on it. I just drilled a hole here so that I can run the wires down to the switches. I think with the back panel on, this is going to be too close, and I didn't think there was going to be enough room, and I didn't want to reuse this hole because there's already a couple wires in this. They didn't put any grommets on those holes. What's the disadvantage of that? Well, over time, if these wires rub against that hole and there's a sharp edge, you could fray the wires, right? That's why I'm using a rubber grommet for protection of the wires. But I am going to be feeding quite a number of wires down this thing, so I wanted it to be big enough. And that's probably like it's probably a little bigger than 1/4 of an inch, maybe 5/16 or something. I don't know what size it was. It was just, I eyeballed it based on needing probably like 6 or 8 wires or something like that to have to go through that thing. Let's go ahead and get started on the easy ones first. Okay, so we're flipped back over. What's next? Yeah, remember I said I wanted to shore up a couple of things? That's just essentially stuff that I know I've been meaning to do, but until I got back into soldering. What I don't want to happen here with this cap, and I noticed this from the beginning, and I said I would do it later, so I'm going to do it now, is this is ground, right? This is the negative end of this cap, and this is going to a ground lug. Out of all 3 of these little tabs here, the middle one is the one that's bolted to the chassis, and that's ground. But what I don't want to happen is this cap start to turn this way, and this ground wire, ground lead, touch this red one here over on the left, because that's high voltage, and I don't want to ground out the high voltage, right? So that would cause a short. That would probably cause a fuse to blow. If you're lucky, the fuse will blow and protect your amp, but you don't want that to be exposed. And since the position of it, I would feel safer just putting some heat shrink on this. So I'm going to shore this one up. So this is why I wanted my desoldering pump. Let me just make sure it's not super full yet. You really got to make sure you clean these out if you use them a lot. So I got rid of a little solder. I'm just going to resolder that. But in the meantime, I'm gonna take this lead and straighten it a bit. And try to straighten it. And let me get some heat shrink. So normally I wouldn't normally heat shrink a negative end that's going to ground, because heat shrink is to protect, you know, something from touching. It's good that this is going to ground, but I'm still doing this one because it has the potential to touch this lug here, and putting heat shrink over one of these lugs, it's not as effective. It could pull off of there really easily. But this is not going to come off of this lead, so it's just, I'm just doing this because of proximity. I don't want to risk screwing something up by this just moving slightly, and all of a sudden, bam, I just caused a short to happen in the amp, just based on where its position is in proximity with other stuff. So I got a piece of heat shrink, small piece. I'm going to cut it to size. Grab a lighter, heat it up, shrink it on there. That's it. That'll provide enough protection. See what I mean by that? If this moves now, I don't know if you can see that, but if this moves and it touches against this tab, this lead is protected. So that means this tab is not going to get grounded out. Just little stuff like that can make a huge difference, because stuff will move around in an amp, you know. You're on a bumpy car ride or whatever and something moved, and now you're wondering why your amp doesn't work. So we're not going to be sloppy here with this. We're going to protect it just in case. I'm still going to also bend it so that it's not literally touching right now, but if it happens to move, we're good. So let me go ahead and pop some more solder on this. Make sure I got that. I may wind up using that ground lug. I'm not sure, for something else. So I left it a little bit open. I didn't fully cover it with solder. This end's going to have high voltage on it too, but there's nothing here that it can kind of bump into. Same thing with these lugs. They have high voltage. There's nothing they're going to bump into right on the other side of this for the moment. So they don't need to be, obviously you don't want to be sticking your fingers in there when it's on. There's any one of these connections in here, tube socket pins, they can be carrying high voltage and shock you. So you should not be ever putting your fingers in there with the amp plugged in, at least. So I'm just for safety going to do that. There was something else I was going to do too, and I forget what it was. Oh, I think I'm like, yeah, that'll be part of the enhancement. I don't think I need to do that anymore, because we're actually going to add a cap to this as an enhancement through the switch, the bias resistor. You know what? I know what I wanted to do. I wanted to change that bias resistor, not the value, but literally change it to a new one. It's working, it's fine, but it is 60 years old, and it's probably taken a lot of heat over its life. Doesn't appear to be discolored, but I would feel safer putting a brand new one in. So it's 150 ohms. Let me just check. I think it may have drifted slightly in its value. We're going to check that right now. I probably showed this earlier on the video, but for me it's probably been 2 weeks since I did that part of this video. So I just want to check it. So let's see what the value is. All right, roughly 154, 155 ohms. That's fine. This one is, let's see if you can see this. This one's also rated at 150, but let's see what its actual value is. Yeah, 148.8. So within 5 ohms, it should be fine. This is setting the bias. Let me just see if I have any other ones. This may be my last 150. Yeah, I don't think I have any other 150 ohm resistors. Okay, well, we'll use, as long as this will reach. I think it'll just reach. But I'd feel safer using this one. This is what they call a wire wound cement resistor. It's 5 watts. It's more wattage rating than this guy. This guy's probably about a 2 or a 3 watt. Probably I think it's about a 3 watt. But this is a 5 watt. So it means it's going to handle even more wattage, amperage, heat, and everything. It's just a little safer. So that, you know, the bias itself is going to stay stable and protect the power tube from overheating, crapping out on us. I would rather just remove that, change it out, have a new one that's higher rated and hasn't been used for 60 years. So even though this one's not bad, I mean, it could be used again, it could be put in there. I'd feel safer. Just swapping it out. Alright, now this is going to be one of those ones that's going to give me trouble, isn't it? Because they wrapped it around like multiple times. Okay, maybe not that much. Hold on a sec. Yeah, even the solder around here is kind of crusty. All right. Still with me? Hopefully you are, because I can't hear you. Yeah, just cleaning off this pin. And the other one I don't need to worry about, but I am going to just throw a little bit of alcohol on that. Just because it does look a little dull, and that's a super important pin to have a good connection with this resistor. That's what's going to set our bias and protect that. Boy, that does look really dull, not shiny. It's just that old solder that's on there. I almost feel like I need to sand that off or something. Give me a second. I'm being a little bit anal about this, but even if you solder something and if it's not like pure bare metal, you might not have as good of a connection as you think. Even though you'd be like, no, it's soldered, it looks good, it's fine. Yeah, but you're soldered to this old solder, which is not conducting as well as it used to, because it's all crusty now. Just trying to clean that one pin off a little bit. I think it's a little better, but still. All right. I know you can't see the angle that I'm seeing on this, but it's still not looking super shiny. It's better. It's definitely better than it was. Just taking some of that layer of old crusty solder off of there. All right. I think that's good enough. We'll go ahead and put this new guy in. And to have it floating up in the air is a good thing, because it gets air under it, keeps it cool. I'm just going to start with this side and tack it in on this side real quick. Make sure. So this is the ground side. There's a lot of stuff going to that ground lug. Okay, I'm just going to bend this over just enough to crimp it in place. And I think for this one, I'm going to put a little bit of flux on it. Just a sec. Because the flux will help also prepare the surface for the solder. It'll remove oxidation, things like that, once it heats up. Okay. This, hopefully, there we go. Yo, it's looking nice and shiny now. just need to make sure I get it in there good. Hold on a sec. I moved it before it's set. So I just want to redo that real quick. There we go. Alright, I should be able to pull on it. It's not coming out of there. Alright. Alright. I think that's good. So it's got some air under it if it gets warm. And that was it. Okay, so we shored that one up. This is good. A couple of these things we're going to need to unsolder to put the mods in, but we'll do those one at a time as we get to them. I just want to see if there was anything else. Some of these really thin wires, I feel like I want to replace them with a better gauge, better quality, but I'm not going to get into all that right now. I mean, this amp has worked for 60 years. As long as they don't, the integrity of the wire looks okay, I think we'll be all right. Yeah, all this stuff for the tremolo circuit looks good, and I'm not going to mess with that right now. Nothing there that I need to add enhancements wise. I was going to originally thought about giving it an intensity control, but I like the intensity on this. I think it's good. I don't think it's as crazy extreme as the one on the Skylark was. You can still hear your note underneath when you're playing, and it doesn't completely collapse out to total silence as it's wavering, you know, and you're using it. You can still hear your note a decent amount. So I think we're good. All right, well, if I see anything else to shore up, I'll do that as we're doing these enhancements. So let's go ahead and start the next enhancement. Okay, let's go right down the line. First one, boost switch. That's going to be the one all the way on the right of my panel. And that's the one where we're going to add the point, where is it, 2.2 cap to this input resistor here on the cathode of the V1, the first gain stage. So really what we're trying to do is we're trying to just put this cap around this resistor, this lead on the ground side, this lead on the pin side, the tube side, like this, but we want to make it switchable. We want it to be switch on, switch off, switch on, switch off, switch on, like this, right? So all we're trying to do is put this in here. So since I tacked this into a circuit before, I'm just reusing it. I'm just getting some old solder off that doesn't need to be on there. I think I need to clean my gun out. It's the one thing about these is you have to keep them clean. So you have to make sure you get old solder out of there and stuff. Definitely some chunky pieces of solder inside here. All right, hopefully that'll do it. Yeah, it sounds better. Let's make sure that's sucking up. Yeah, better. All right, cool. Back in business. So what I'm going to do, what I had planned to do with this is I'm going to put this cap in and have it always connected here to the pin of the tube on the positive side, and make the switch attach one of the other end of it to ground to this side. Now, it doesn't necessarily have to be this ground. It could be any other ground. But I don't want to add it to a power amp ground because that could potentially cause noise. This ground here on this input jack is probably the best place to put it. But I could put it over here too because this is part of the preamp ground as well. It's just a different ground. But it's only another couple of inches to go over here, so maybe it'll also make somebody's mind think, oh, I see what he's doing. If somebody's working on this, he's putting this cap in and out of circuit right here on this gain stage. So it'll probably make more sense if I just run the wire over here. I was just trying to figure out what makes the most sense for wiring purposes. Yeah, it's shorter to go here, but here it'll make more sense to somebody. And I don't think a couple extra inches of ground wire is going to hurt anything or affect the signal. So really all I need to do is pop this in here and run a wire from it down to the switch and one back up out here. So let's go ahead and do that. So what I'm going to do here is there's a hole for there's a little hole here for the lead, and then I'm gonna, well actually I'll go ahead and solder that in place first, and then I'm gonna bend it. I just want to give it a little crimp and turn it over. There we go. Okay. I wanted the label to be up so people could see what it was, but the label's starting to rub off of it. Alright, then I'm going to turn it this way, and I'm going to go ahead and use a black wire, because typically I like to use black wires for ground, things that are going to ground. Not always necessarily, but a lot of people do that. A lot of people use black or green for ground connections, but what I'm going to do here is I need to connect it to this part of the cap. So I'm going to go ahead and just J hook it, which means I make a little J here, right? And then I'm going to make a little J. Actually, I'm going to go ahead and snip this off because this is old, some old solder. Okay. Make a little J hook here. Perfect. Right, and now they're just connected together. And now, even without solder yet, they'll have a nice little mechanical connection. And then I'm going to go ahead and cover that as well, because I don't want that to prematurely ground out without you actually hitting the switch. You need to hit the switch. So, alright, so just connecting this wire to the ground side. And then, while I'm here, get a piece of heat shrink. Doesn't need to be very big, just to protect that end of it. I don't think that end would ever get grounded out, but it would have to literally touch the metal of the chassis, and this isn't even really that bare metal. Alright, so now I'm going to run this wire down to the switch. Okay. Hold on a sec. Let me move this wire over just a little bit. There we go. So it's connected to the cathode. That's pin 8. Right? 1, 2, 3, 4, 5, 6. Whoops, sorry. 1, 2, 3, 4, 5, 6, 7, and 8. Yep, and that's 9, which is the heater. This is 8. Okay, so it's still the first gain stage because it's right where the input goes into pin 7, which is the grid of 1/2 of that 12AX7. The other gain stage is this pins 1, 2, and 3. 4 and 5 are heaters. 1, 2, and 3 is the second gain stage. That's just the way they designed this. It's 6, 7, and 8 are the plate, the grid, and the cathode, and 1 is the plate, the grid, and the cathode. 1, 2, 3 of the second stage. But the first stage is where your guitar signal comes in. So that's 6, 7, and 8. And it's coming in, the signal itself is coming through these resistors here from these input jacks to the grid. This is the cathode, which is essentially biasing the tube. That's why we're adding this cap to it to give it more gain boost, because it has no cap. It's only got this 4.7K resistor. We're adding a cap with the switch. Okay? And then I'm just going to cut another piece of wire, but this one's got to be a little bit longer. It's got to go down to the... I'll cut it longer than I need probably, but I can trim it up. And essentially what I want to do is I'm going to go ahead and J-hook this, and I just need to, I can either attach it to the resistor itself, or probably better would be just ground it on the jack itself. So let me just see if I can. There's already a lot of stuff going into that jack, but let's see. Hold on a sec. I just need to make sure I have enough exposed to push it down in there. I'm gonna try to get my gun here. Get it in that hole. It's kind of difficult because there's so much going on over there. Let me see if I could do it like this. Trying to push it down through a hole and heat it at the same time, but kind of coming around from underneath here to apply the heat. Alright, I think it's in there. I can't really tell for sure, but I'm going to add just a little bit of solder to secure it. Yeah, see, I knew it wasn't quite all the way in there. Damn it. We'll get it in just a second. Now that we've got fresh solder on there, maybe that'll help a bit. Ah, you sucker. So some of these I'm using different pliers because like this one's got grip and hopefully it won't roll around on me. But it's thicker, so it's harder to get it into this little space. There we go. Come on. There we go. It's totally through now. Okay. Alright, I'll add another dab of solder if needed, but that's definitely in. Alright, so that's grounded where the resistor end is grounded, and I'm going to run this down to the switch. Okay. Probably just run it right underneath this cap. Perfect. Okay, you see what I'm doing there? Pretty simple. We got this end of the cap going to the cathode, pin 8. This one is going to the ground, the same ground as the 4.7K. So it's like putting this cap around this resistor. One end's here, one end's there. It's just not physically around it. And the switch is going to connect those two together. This is going to connect this one and this one going back to ground together. So when the switch is switched up, it connects the two, and this side's grounded, and that puts this cap in that circuit. Even though it's connected to the positive end or the cathode all the time, that's fine. It won't be engaged. It won't be engaged until the other end of it is grounded. So that's why I decided to do it that way, is because it's just switching a ground on. It's very similar to what you would do with a foot switch operation, right? A foot switch typically is kind of like on and off, right? Depends on the foot switch, but let's just talk about in the simplest terms. When you click the button, it's not connected. You click the button again, it's connected. And a lot of times, like if you had a boost button for your foot switch, like your amp, you can put on the high gain mode, bam. It might be doing something like this where it's just grounding out a component, which puts it in the circuit, and that's it. And there's no high voltage going to anything. And your foot switch can be a really long cord, because all it is ground. There's no signal going out to that. It's just ground, right? It's just everything connected to ground, or not connected to ground. So, all right. So now I'm going to try to flip this over to complete the circuit. I could do some more mods up top and wait, but I think just to complete this so you can see what the full result is. Now, this is the switch that we're going to do it to. It's the one all the way on the right when we're looking at the back of the amp. So when the way I was talking about this when we were talking about these mini switches, when I put this on continuity mode for beep, right? The switch is in its down position. Even though the amp's upside down, it's in the down position. These two pins on this switch has two pins. If I touch these, there's no continuity. If I switch it up, now there's continuity between them. If I switch it off, no continuity. Switch it up, continuity. It's on, right? Those two are connected. So all we need to do is connect these to these, and it doesn't matter which one. We're just saying, connect these together, don't connect them together. Connect these together, don't connect them. Very simple switch operation. So it doesn't matter which one you do for an on-off switch, just as long as if the switch was the other way around, I would just spin it like this. I would literally just loosen it a little bit and turn it if I had it the other direction. The wrong direction, meaning up was continuity, sorry, down was continuity and up was not continuity. If it was like that, I could just literally turn the switch upside down and then it would be in the right orientation. Alright, so yeah, I'm just gonna just take this one to right here, chop off just a tiny bit. Okay. And I know this isn't a very good close-up of what I'm doing here, but I'll just talk you through what I'm doing. There's a little hole in each of these lugs. So I'm just bending the wire over. Again, this is solid core wire. I'm just bending it over 45-degree angle, and then I'm going to make another little tiny 45-degree bend, so it's kind of like a J or a hook shape, and I'm just going to set that down in through the hole, just like that. And in this case, I'm not going to go ahead and bend it over, because if I have to disconnect this, the more heat you apply to these pins, the more likely you're going to melt or destroy the switching mechanism. These are very sensitive to heat. I've mentioned that before in this video. I don't want to get this thing and wrap it around the thing, and I just want to set it down inside with this 45-degree sort of little U-turn. So it's literally going up, over, down through the hole, and that's good enough. Because if I need to disconnect it, I can ruin that switch if I have the heat on there for a long time and I'm trying to unwind something. My thought is, if you don't have enough solder on there and you pull on it and it comes loose, you need more solder, right? But in this case, you don't need much at all. I'm not going to dwell this too long, just enough to cover it, to cover the wire and the little lug. And if I pull on it and it's not coming loose, that's good enough connection. So again, other components that can withstand more heat, I probably would have put the soldering iron on there a little bit longer, but this is fine to do it this way. I've been doing it this way for a long time. I have ruined a lot of switches by going, come on, man, it's, I'm trying to get it off. I'm like, oh, I connected it to the wrong lug, I need to switch it, and I'm putting the soldering iron on there and I'm like trying to uncurl my circle of a wire that I looped around, and now the lug pulls out of the switch and it's no good anymore, right? So you definitely want to be careful how long you're applying heat to these things, these little mini switches. The plastic will melt because that little lug is going down through inside of there, and you're just going to melt the plastic around it, and it's going to cause that problem. So I'm doing the same thing with the other one. I'm just going into the top lug now, right here, and I'm not even going to wrap it around. I'm just going to make sure that it stays in place. And if you can't get it to stay in place, sometimes just grabbing it with a pair of pliers or something like that and holding it, just as long as it stays down in through the hole there. And I give it just enough heat for a few seconds, and that's usually good enough. If you give it like 6 seconds or so of heat, that's probably enough to ruin it. Yeah, as long as it's not pulling out of there and that lug doesn't get loose if you shake it. So it's not loose, it's stable, the wires are stable. I'll go ahead and just trim the little tiny tips there just so that they don't touch anything. And here's what it looks like close. Hopefully you can see. I know it might be a little out of focus. I'm going to try to get it in focus. But see how I did that? I just wrapped it around. That's all you need. And as long as you're pulling on them a little bit and they're not coming loose, that's going to be perfect. Yep. And these don't get loose. If these lugs here if you can kind of take them and they wiggle, that switch is probably not going to be any good anymore. Like they're in there tight, right? But if you apply too much heat, then it's going to melt the plastic around there, and these are going to be loose in there. If that happens, I would just start with a new switch. That's my advice. Even it might work for a little while, but eventually it's going to break down and stop working. So if you're careful with the heat and you're pulling on the wires and they're not pulling out and they don't feel loose or anything, then I think you're solid. Okay, that's that one. That's the boost switch. So how can we test it now without turning the whole amp on yet? The continuity test, very simple. We can, well, I don't know if we can test it from the top here, but we already essentially did. The reason is I covered this so it's not exposed anymore, so I can't put my lead on this little thing because we covered it with a piece of heat shrink for safety. If it was uncovered, I could say, does that, when I switch this up, does that connect and have continuity with over here, the end of this? And if I switch it down, does it not have continuity anymore? Same thing. But we already checked it before we actually wired it up, so we're good. All right, so that's the boost. The next one is this guy. So this one's a little bit more complex because we have a 3-lug switch. It's still only a 2-position switch. It's an up and a down. All these are just up and down. They're not 3-way switches, but it does have 3 lugs, and that means we want to have 2 parts, and we want to swap out 1 part for another part. And this is the part right here, this 0.01 cap. So this is the voicing switch. I'm calling it that because in this mode, the original mode is going to be the down position of the switch, and that has a lot of bass notes. But when we're really cranking the amp with the gain, remember when I was playing it, everything kind of got blocky distortion and got a little fuzzy. So let's cut some of those lower frequencies by swapping that cap with a lower value. Well, where is he? Oh, here he is. He was hiding. With this guy, a 0.0022 cap. The indication on this orange drop is 222J, but that's the value of itself is a 0.002 UF cap. If we want to double check that, we can use the LCR tester. I'm just going to put it on 2 UF. And it should be 0.002. I'll put this here so you can see it if it will stay. See, 0.002. Okay, and this one is a 0.01. So we're just saying when it's in the down position, the stock position, you can see that this one isn't exactly, although I may need to disconnect it from the pot. I don't have it soldered right now. I just kind of got it tacked in there. Here we go. If I disconnect it, let's see if it's closer to 0.01. No, it's 0.014. So this value isn't exact. It's labeled 0.01, but it's almost like a 0.014, slightly higher than that. That's probably just because it's kind of drifted over time, its value, or the tolerance level of this was higher, and it's just not its same value. Even stock, when they put it in the amp, it might have been a 0.013 or a 0.014, right around that same thing, and they just threw it in there. Not a big deal, but I'm going to leave it because it's the stock cap. So essentially what I want to do is I want to say down position, I want this, you see where this cap is going. It's going to this lug here, which is the plate of the first gain stage, right? So we did something to the cathode of the first gain stage. That's pin number 8. This is the grid. That's where your signal, guitar signal, comes in from the input jacks to get amplified by the first gain stage of the 12AX7. Then this is the plate, which has the high voltage, but this is the output. This is where your signal gets amplified and sent back out to the volume pot, where you can set how much you're going to send back to the next gain stage, right? That's what the volume pot's doing. It's saying, okay, I got your amplified signal from the first stage, all your nice gain and everything with this new cap and whatever, and that's going back to the volume pot, and the volume pot sends it back to stage number 2, which is pins 1, 2, and 3, to do another thing. However, this cap is blocking all that high voltage and just sending the AC guitar signal to that pot, but as it's doing that, it's filtering frequencies out. And in this case, it's letting a lot of bass frequencies through, whereas this case, it's going to block some of those bass frequencies to give it a thinner, tighter sound. And that's what I want when I play in a high gain mode, is to be able to voice that differently. Or if, depending on my pickups, maybe I do want the bassier sound, and I can leave that in the stock position and use the 0.01 cap. So how do we wire that? Pretty simple. They both need to go to the volume pot, right? That's where they're headed. That's the direction they're going, is to that volume pot. So I need to have one wire from the volume pot down to the middle of that switch. And I'm going to go ahead and use a yellow, because I like to reserve red wire for high voltage things, and I like to reserve the black for like ground things, if possible. So either like a yellow or a blue, something, you know, there's not that many yellow wires in here, but this, hopefully, this is not going to contain high voltage, this wire here, this yellow one. That's why I'm not using red. It's just going to be signal going to the pot from the switch, and then the switch, two ends of each capacitor are going to go to each side of the switch. So we need to run this down here to the switch. I'm just going to give myself plenty of excess in case I need to route this around, and I can always trim it up. But what I want to do is I want to connect one end of this wire to the volume pot. Now, you're not seeing this, but I will show you this when I am able to bring it up. The part of the volume pot that this cap was connected to is the lug that's all the way on the right. So there's a left lug, there's a middle lug, and there's a right one on the right. So this is the one on the right. Okay. So all I need to do is just tack this yellow wire in, which is going to go to the middle of our switch. Instead of this cap going straight there. This way we get a choice. We say we can go through this cap, or we go through a different cap that we're going to add in. Alright, so the only thing I need to do is kind of route this, and I was thinking about just trying to take the path of least resistance, which would be to just sort of snake this under here. See how I'm doing that? I'm going to pull it tight in a minute and go down. Okay, and I'm just going to feed it through here. The shorter these wires, the better. This is going to contain signal. And this is the wire that I was talking about possibly using shielded wire, because it does have signal in it. It is going to the volume pot from the first gain stage. I'm not going to do the shielded wire just yet. I'm going to... you know what? I'm just thinking about it. I am crossing over these heater wires. Let me do this. Been doing this long enough now, building amps and stuff, to know that if you run this, which is a very sensitive signal wire, if you run this across these black and white heater wires, like literally almost touching, you're going to get noise. You're probably going to get noise in your signal. Because even if those wires are twisted like they are here, the spot where it's crossing over might not be, you know, it's still going to pick up something. So I'm going to go ahead and run this around, away from those heaters. Even though it might be a little bit further distance wise, as long as it's not going over top of those wires and actually touching them, we might not even need to use shielded wire. But they are fairly close to this hole here, but I'm not worried about that. See how I'm going around this? That's going to actually be better and have less noise, even though it might be a longer path than going straight from here to there. But just moving it an inch or two away from those wires can make a huge difference in... Now the only thing is do I have enough? I think I do. Yeah, it goes all the way down to that switch. All right, I'm going to leave that for now. And then we have to take... I'm going to bring this guy up and out of here for a minute. There we go. So here's the original cap going from the output of the first gain stage that was going straight to the volume pot. What we need to do is we need to send this end, instead of straight to the pot, to one side of the switch. And it's going to be the side of the switch that's on the very top, because remember how I said that the switch up is down and down is up when you're looking at it from the side? I'll show you that when we get down here. So that'll be on the top end, and that will be the stock setting when the switch is in the down position. Okay, and then we have to take this one, and I just have to figure out where I'm going to place this. So I think what I'm going to go ahead and do is literally just keep it attached to the same lug, right? Attach it to here, and probably just set it on top of this other cap. I think that'll be fine. Something like this. It doesn't need to be this long. I'll shorten these, but something like this where it's going to go to there, and then I'll have a wire J hook to go down in there, and that way this end and this end are going to go down into the hole here using wires, and then back up is going to be the one where it goes back to the volume switch, which is this one we just ran. So the volume pot. Does that make sense? So this is output. One of this is going to be the output. These two are going to be over here, both connected to the same place, and they're going to go either through this cap or through this cap, and then that switch is going to decide which is which and send it back to the volume pot. Whereas stock was just this one can go to the volume pot. In this case, this one or this one can go to the volume pot, but never both of them at the same time. There is a switch that will allow you to do that too, whereas if you wanted to have both of them go, but that really would make, that wouldn't even be productive in this case, this particular case. There are applications where that might be useful to add things on, like adding resistors in series to, you know, give more resistance or something like that, where you switch and add another one, add another one, add another one. But in this case, no, we don't need that. All right, so let me stop talking. Let's actually do it. So I just want to see how much I need, and I'm definitely going to put some heat shrink on this because I do not want this to touch any of these other pins. I'll go ahead and tell you what. I'm gonna go ahead and just chop off like 1/4 of an inch. I can always trim it a little bit more, but I can never put it back on if it's not long enough. So there is a open hole here on the pin. Go ahead and just crimp it over and solder that into place with all the rest of these guys that are going to the same pin. Sorry. It's hard to get this in here without burning up something. There we go. Oh, that should do it. Just want to make sure that none of that lead that went through there is touching ground, touching the chassis, because that's high voltage. Oh shoot, I wanted to heat shrink that first. At least this one. All right. So I want to make sure that hang on. This is a really skinny piece of heat shrink. The reason I want to do that is because I don't want it to accidentally, if it moves, touch any of those other pins on that tube socket. Hold on. This piece is so skinny that even that little bit of solder wouldn't let it get on there. Okay, so we'll just go ahead and heat that up. And if alright, so again, just put it in the blue part of the flame, and if you put it in the yellow part of the flame, if you're using a lighter, it can discolor if, like, let's say you're using white or yellow or something like that, but just enough to shrink it up around there. And then get this back in here. So now it has insulation. Come on. There we go. I need to put a little more in there because I don't like this. This one lug has so much stuff on it. Just want to be sure that everything's... Whoa. Hold it. Hold it, hold it. I just dropped something, but I don't know what I dropped. Okay, there we go. So see how this is now, this is heat shrunk, so even if it bends over, it's not going to worry about touching anything there. Now I'm going to go ahead and cut off most of this lead here, because I'm going to run, this is where I'm going to run a wire, and I need to also run a wire from this end of this this cap. Now this cap could come over here too now, which I think I will do, and that way they're just sort of kind of hanging out together. There's no point in running it this way and then running another wire over there. The shorter the better. So I'll go ahead and I'm going to leave this lead in case somebody wants to reconnect it as original. If they want to disconnect this panel and make this totally original, they don't have to run a wire from this lead to the pot again. You can just literally reconnect it to the pot. So all I'm going to do is, I'm not going to chop any of that off since it's an original part. I'm just going to go ahead and run that wire. Now, one thing that would be helpful here is to do a little color coding. I'm going to go ahead and use blue for original. The original component, the original circuit. Since we are already using yellow for kind of the both, right? The one that's connected to the middle. I'm going to use blue for this, and I'm going to use probably something like orange for, or brown or something for the other cap. So that way we know when we're looking at the back of the panel what's going to what. If I use all the same color, it might be hard to tell what's what, but now I can see by color coding. Okay. All right. So I do want to protect that. It's not going to have high voltage on this side of the cap, but on this side there is. So everything from past the caps here that are going down to the switch, there's no high voltage. These caps are blocking the high voltage DC, but this end of it is hot. All right, so I want to fully protect that from anything touching it and grounding it. So again, heat shrink comes in very handy. So I got a little bit thicker piece of heat shrink here just because it's not as thin as this. This lead's a little thicker and this wire's thicker. So we're going to send the blue down. That's going to be the original cap value and color. And then this cap here is going to be, actually I think I'll do it like this. Blue. I don't need to worry about heat shrinking this one because it's so far away from everything else that it's not going to move. Even if it did move, it would go up and not touch something else. And it's already connected to this resistor here, so it's supposed to be connected to that resistor. Alright, so this one, let's grab a different color. I'll just use orange. I think blue and orange are opposite colors, right? Is that right? Or blue and yellow? I always get that mixed up. I think it's blue and... Wait, purple and orange. And blue and yellow. I don't remember. You guys probably know if you went to grade school. We had the color wheels and you had to know what the heck was opposite of what. But yeah, it doesn't matter just as long as it's different. So the other reason this is cool that it's orange is because we're using an orange drop cap. And we don't have to use an orange drop cap. We could have used a yellow Mallory cap or something like that. I just happen to have this value of 0.002 in orange drop. It's not really going to sound any different. I mean, there could be a microscopic difference in audio, but honestly, most people's ears would never hear that as long as the values are the same. Alright, so let me just grab a piece of this to protect. Wait, did I solder that? No, I didn't solder it yet. Okay, so we J-hooked it, soldered it, put a piece of heat shrink on it just to protect it from anybody touching it. Pop this down in there, and then we can wire the switch. Alright, and what I might wind up doing possibly is putting a little zip tie or something around this guy just so that they don't move. I'll do that later, but it'll just keep things more stable, but nothing's touching anything else and everything's heat shrunk over here, so I'm not worried about anything getting grounded out or anything like that. So here, take a look at it close. I'll bring it closer for you. Let's look at it from this angle. See the volume pot there? See the yellow wire is on that third lug, but it's going all the way around here. Hold on, let me just hold this like this. And we have these three caps. We have the new orange one. We have this original one. And this is the cap for the boost feature, so that's a totally different one. But these three, so all three of these caps here, if we needed to put this back to stock, we could just snip these out, these two out, and reconnect this one to the volume pot. That's it. So far, that's all we would have to do to make this totally stock with no control panel or anything. Snip out this, snip out the orange drop, reconnect this one to that right side of that volume pot. Sorry, right there. See how that works? And as far as everything goes, you can see down in here, none of these are going to touch anything else. They're all, this one's heat shrunk. This is the one I worried about the most. And this guy is over here. He's kind of coming out and around. And it's pretty stable. I can't move it without really pushing a lot of pressure. But these guys I might wrap a little zip tie around just so that they're not going like this in the end, so that they're not going like that, right? Movement over time could cause problems, something to get dislodged or get loose or whatever, right? So let's go ahead and flip this over, finish the switch side. Give me 1 second. Okay, so now we're to the voicing switch, which is the second one from the right here. And remember the yellow was the to the volume pot. So all I need to do is just grab that, and I can snip off about just a little bit, but I think I gauged the length of that almost perfectly. And again, I'm just gonna do a 45-degree angle to flip it over, and another little turn, go through the center lug. Remember, this one's to the volume, so it's always going to go in the center. For this this type of switch, which is on switch, right? It's either on one side it's on and the other side it's on. It's never off, right? It's either these two are going to be connected or these two are going to be connected, right? The middle one's always going to be connected to either this one or that one. Always. Up, down, it's always going to be connected. So that's the middle one. And then the orange is the new one, right? So we want that to be when we flip the switch up. And when we flip the switch up, the amp's upside down right now. That's going to be these two guys right here, right? And just to check, just to be sure, if you're not sure, we want the middle and this one. That's the up position. That's where we want to connect the orange drop to. If we have it in the down position, we don't want the orange drop in the circuit. We want the original sprog cap, which is that blue wire. So we want to connect the blue wire to that lug. Okay, so just take this guy, turn him over. I'm just going to solder all three of these at once. So let's go ahead and expose a little bit of this wire. I don't know why this orange one is always a lot harder to get exposed, but flip that over, and then the blue one. Push it back. Expose it a little bit more, make a turn, get it down into this lug all the way down here. Come on. And if you screw this up, the order, you can always unsolder, resolder, or you can literally, if you have enough wire, you can literally just unscrew the switch and flip it upside down. I've done that plenty of times. So I was like, you know what? That's actually going to be safer than me trying to apply more heat to one of these things and risk breaking them, right? Or, you know, causing it to melt and not function. Okay, so we have 3 wires in place, and we can clean up. I might put a little zip tie around them just to keep them nice and neat when I'm done here, but for now, I just want to solder it just enough to get it in place. Okay, that one I didn't quite get, and I didn't want to leave the heat on too long. That should do it. And then the third one, there. Literally just 2 seconds is all it really needs in this case. As long as you pull it and it's not wiggling and the wire's not coming out, meaning that the little lug is not wiggling, and that's secure, this is secure, and none of them are touching each other. Because if you had a lead really long and it was touching the other switch, then it's not going to make it switch properly, right? If you have two things connected. Nothing should be connected at the switch. You let the internals of the switch connect the wires together. All right, cool. So for right now, I'm just gonna put one tie around it, just because I'm gonna be flipping this thing upside down and all that. This will just help stabilize these wires a little bit. Just for now, and I might do the same with these. I don't know. Don't need to go too crazy with that, but even just that one little tie keeps this bundle nice and tight and secure, right? So this is what it looks like. Oh, hopefully you can see. And again, if I pull on them, they're good. Nothing's loose. And then here's the switch, and this is the orientation, the real life orientation. So it'll be up, on, and so on, right? Just like that. Okay, so far so good. Move on to the next one. That one's going to be the that bias stabilization cap, which is that 100 UF cap, and it's going to be wired exactly the same way as we did this first boost cap. It's either wired into this, around this resistor, and so that's literally just that on-off switch. It's either on the off position, it's not in circuit, and on the on position, it is. So it's going to be like this: the positive end over here, the negative end over here, and we're going to run it just like we did that. So that's next. Let me just clean up here and I'll be back. Okay, before I move on to this third one, I'm just going to go ahead and secure these now, as I mentioned. I think what I'll do is this is just a little sort of security here for these two caps to keep them from moving. That's pretty good. And then if I just maybe put one around, so that's just one around the two leads of the two different caps to choose between the two for the voicings. And then maybe just one around, and I'm not going to do this one very tight, but one around the other cap plus these guys, just so that kind of makes it all one piece. Maybe just, there we go. All right, now they're secured, like they're not going to move. I mean, very, very slightly, but they're so much tighter now, so they're not flapping all around. Okay, good. All right, so here's the third mod. This is the bias stability cap, although I'm going to label this, I think, on here. Let me show you my screen real quick. So you see where it says, let me zoom it in. So the mode is tight or loose. I think that will make more sense to like a player. So essentially, it's like a mode. You can set the mode, right? So this is going to add that stability cap over the bias resistor, and that really tightened things up and made the volume less sag, right? It had less dropout sort of volume, and it sounded like it increased the volume a little bit. Just feels like it gives the amp a little more power and stiffness. So with it in the up position, maybe what I'll do is call it like stiff or loose or tight or loose, something like that, with a label, and that way it kind of tells you how you want the amp to respond and feel. Because I feel like between that and the rectifier option, which we haven't even tried yet, but in previous amps I've done the rectifier option switch, that'll definitely stiffen things up too. It'll increase the voltage on the B plus a bit and really just make it feel a little more powerful and a little more stiff. So I'm not sure which one's going to have the greater effect, but you know, you'll have the option to do one or the other or both if you want to play in that mode. So what we need to do is essentially just put this one cap, which is this 100 UF microfarad, 100 microfarad UF, 100 volt DC. It doesn't have to be 100 volts. It could probably be like 50 or even 25. But I like the 100 microfarad value for this cathode bias type amp. It seems to work really well without cutting out a lot of bass frequencies, right? We've already done that essentially on the mode switch, right? Or on the voicing switch with this cap, where we can cut out some flubby bass frequencies. So that's already there. I don't want to necessarily cut any out on this overall power tube bias, but we need to put the positive end here to this power tube, which is pin number 3. Yeah, pin number 3. And then the other end goes to ground, right? So what I was going to probably do for this is, I think I'm going to take the positive end of this and leave this cap sort of like this and run a wire. This cap's not going to get hot or anything, so I don't need to worry about it floating or anything like that. The only thing that may get a little warm is this resistor, and it won't get like super hot. It may get warm. But this one I can run a wire down here, and then I'm going to need to run another one up to the ground up here. And the reason I want to do it there is because that's the power amp ground. I could use this ground, but that's part of the preamp ground, and I don't want to risk introducing noise into the circuit. So if I keep it, it is a little bit longer of a wire to run for the ground end of this cap, but it's better to do it that way because of these grounds. If you separate the power amp grounds from the preamp grounds, you definitely will have a quieter amp in general. Now, for this little circuit here, it might not matter as much, but it's good practice because I have had major differences in larger amps like Marshall JCM 800s that I've built and things like that, where separating the power amp grounds from the preamp grounds made night and day difference in noise in the amp. So I think what I'll do is we need to run this about right there, and I'm going to go ahead and get a piece of heat shrink just to be sure that this is protected, and it doesn't need to be very long. Actually, probably about half this size of heat shrink. But essentially what I want to do is just protect this from touching the heater pin. Yeah, that should do it. Alright, so let me trim this back. Shrink this on. I have to plug back in my iron here real quick. Just give me a second for that to heat up. But yeah, we're just going to put this guy right in here. So I'm going to turn it this way. And while that's heating up, I'm going to get a black wire because that'll be the ground side. Where's my black? Actually, this is probably hot enough for me to put this in. So it just needs to go into this pin right here. And I'll just take that lead and bend it over. So there's a good mechanical connection, and just hit it with just a tiny bit more solder to make sure it's got both the cap and the resistor solid. Alright, pull on that resistor a little, it's good. Pull on that cap, it's good. And no parts of the lead are touching any pins, and if this happens to move and touch this pin, it's insulated now, so it will not ground in, it will not ground out or anything. All right, so now I need to run this down into here, so I'll go ahead and shorten the lead. Let's just do the old traditional J hook like we've been doing. It's been working good. Grab a piece of wire, and it just needs to be able to go down through that hole. We still have a couple more wires to go down in there. I hope we can squeeze them all in. I think we'll be okay. We've got 2 for this feature, and then we've got the diode rectification, which I think we might need 3 for that one. So I hope we can squeeze that many more in here. I don't know if we will. Worst case scenario, I could widen the hole a little bit, but it is starting to get a little tight. Alright, so I just J-hooked that lead that's going down in for this negative side of the cap. And I'm not going to heat shrink this side of it because there's really nothing else that this can touch. And if it even touches anything chassis related, it's going to be going to ground anyway. So yeah, it'll be fine like that. Okay, see that right there? That's the connection. And it's up off of the ground. It's not touching the ground at all. The chassis part. Alright, that's soldered, and we just need one other side to come back from the switch up to the ground side of this resistor. So the positive end of this cap is going to be connected all the time to this, but then it will only be in circuit when the switch is turned on, once it's in the up position. So we need to run this up to there. So that's going to be, I just want to make sure I have enough. These wires look like it's pretty long, but hopefully I can trim a little bit of this. I think what I'll do here is go ahead and run this under here. And push that down. Just sort of feed it in there until I get... Yeah, I think that's way more than I needed actually, but that's okay. I usually save, if I have a couple of inches of wire like this, I usually save those pieces and try to reuse them on other projects, so I'm not wasting a lot of wire. And stuff does add up. It does get expensive. Alright, so we just need to connect this in here on this pin, which is ground. And all of our power amp grounds are going to that pin. So the red and yellow striped wire is the center tap of the transformer. That's going to that pin. The ground of these filter caps is going to that pin. The bias resistor is going to that pin. And this here, which was the cathode of the tube that's controlling the tremolo, which also is wavering and adjusting the bias itself to make that effect happen, is also there. So there's a lot of things going to that. 1, 2, 3, 4 components. We're going to add a 5th one, and that's just the end of this cap from the switch, basically. So hopefully we can fit it. If we can't, we could always wrap it around this resistor. I know we're getting quite tight here, and I just don't know if we'll have enough room to put another lead through here. Yeah, I don't think we are. I don't think we're gonna have enough room. There's just too many things going through one single hole, and I don't want to mess up the integrity of that tube pin, the socket pin. So no big deal. If I was gonna put this cap in to be in there full time, or if say Kalamazoo did, I would literally probably just attach it to each side of this resistor, so that I'm not. So I'm just gonna go ahead and attach it with a little J hook like this, which will be a totally fine connection. It's mechanically sound, and people will obviously be able to see that this is, if they follow the wire, that it's going to this cap. Sorry, I just need to crimp it a little bit. It's hard to get in there. Come on, little guy. Man, that's just really tough here to get in. There we go. Got it. Alright, so it's mechanically on there now. Throw a dab of solder just to hold it in place. There we go. So you can clearly see that that is going to that bias resistor and down into this hole here. Let's do the other side while we're at it to finish it off. And all we have to do, just like that first enhancement we made with the boost switch, where we just put a cap in and took a cap out of circuit with the on-off switch, the same exact thing we're going to do with this switch. It's also an on-off switch. You see the colors are the same. This lighter blue, and it doesn't matter which one we connect to which terminal, again, because it's either down position, they're not connected, up position, they are connected. So the order does not matter here. Which is connected to which. You just need to connect one to one terminal and the other to the other. The switch will handle putting them in circuit and taking them out of circuit. Alright, so let's expose it. This method's been working really well. Just make a little 45-degree turn. Pop it in there. And then the other black wire. Not even sure which is which, but that's okay. It doesn't matter. Just as long as they're both connected to this switch. So yeah, that wasn't too bad. That was 2 inches. Overestimated the length of the wire. Okay, and another little hook. Doesn't have to be very large. It's just enough to get in there. Okay, this one I might need to just curve it around just a little bit because it was touching the middle. Same with this guy. I'm just going to crimp it just a little bit. I'm not trying to like do a crazy wrap around here or anything like that, but I don't want it to move when I'm soldering. Okay, that should do it. Let's do the one on the top first. Just very carefully get ready. Touching both components. Solder on. Solidified. Looks solid to me. Before I solder that, I can see this is still wanting to pop out of here a little bit. There we go. And the middle lug, or the second lug here. Quick, 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 quick. That should do it. Okay, we're going to give him a little test. Yep. Nothing's loose. Secure. There's a little tiny bit to trim. That's it. I think I'll go ahead and, just for consistency, I put a zip tie around the wires just to keep them from moving and stretching out and pulling. Just putting one at the ends here, just to hold them together. And one on this side too. Why not? This might be a little overkill, but it looks neat. And you can tell which wires are which. They're not getting all mixed up and bunched together. And if I need to, I can always put a zip tie at the other end, but I'm going to leave that loose for now. I think that's too much. Don't need all that. Okay. Okay, so that's what that looks like. We're almost done. We got one more enhancement. See? Very simple. Very simple little control panel. Still have a little bit of space. Hopefully we got just enough to fit a couple of more wires for the last piece. And this is the one I'm not exactly sure how I'm going to do. So I'll just keep filming this, and so you can kind of see what decisions I'm making. I just hadn't really thought exactly how I'm going to mount these. Well, I've thought of a couple different ways, but they all required me to put like more terminal strips in here. I was trying to avoid that if possible. It does make it clean and look nice and all that, but I was trying to do it without it, because here's what we need to do. These are the diodes that we're going to use. Actually, you know what? I bought a brand new set of these diodes, and this might be a better brand than these ones that I had here. I'm going to go ahead and use the new pack. This just came because I was starting to run low on this type. But these are the 1N4007 diodes, rectifier diodes. They are good for up to 1,000 volts. 1N4007. These are used in a lot of lower amp rated amplifiers, like 1 to 2, 3 watts of amps. When you get up into the 4, 5, 6 watt amp, sorry, not watt, but amp guitar amplifiers, like the bigger amps, the 100 watt amps, the 150 watt amps, you want to probably use something that's rated a little bit higher, like these thicker guys here. But anyway, long story, these will work perfect for this application to do rectification. Just need to open can't get this open. Sorry, just a second. There we go. And these have a little zipper close, because if you keep the humidity off of these things, it'll keep everything nice and shiny. You can see that over time these are starting to get a little discolored. The leads, I've probably had that pack for years. But these are very cheap. I mean, this whole set of what is this, 100 of them was probably like $6. So they're not expensive at all. And for these guys, I just get these off of Amazon. You know, I just make sure that I pick one that's highly rated by the customers. And there's certain brands like this Chanson. I've always had good luck with all their stuff. You know, I think they make fuses, and they make different parts, maybe even resistors. It's all good quality stuff. So yeah, the reason I need 4 of these, I really only need 2. But I want to have a set as a backup because they're so cheap, and if one fails, then the other one will pick up the duty of the one that failed, and we won't have an issue. So why not just use 2? So the way it needs to be wired, though, is we need to go from where the red leads of the transformer are coming to the tube. That's going to be alternating current. That's going to be AC, high voltage, 250 volts on each wire from the transformer. So the wall transformer is taking 120 volts AC in America here and transforming it into 250 for the high voltage. Then these little guys, when we have it on diode rectification, are going to change that AC from 250 to probably closer to 300. Whereas the 6x4 tube, it's doing the same thing, but it's going to take a little bit longer because it has to heat up, and as it draws current, it sags a little bit, and that's why using these can make an amp feel a little bit stiffer and give it a little bit more power. Whereas this will have a little bit of sag doing it with a tube, and the voltage of DC coming out of it will be a little bit lower. So I think we measured it out at like 285, 275 maybe, I forget. So it went from 250 AC to like, I think it was 275, 285, somewhere around there. Whereas the diodes I would expect to be a little bit higher than that, maybe even up to 300 volts, maybe even more than that. I don't know exactly. how this is going to play, but there's a calculation you can do if you wanted to figure it out. We'll measure it once we get it in place and working. We'll measure it ourselves to see how much higher the voltage does go up to, because I am very curious to see what is the first gain stage, these 100K resistors. What did their voltages actually go up to, because that will affect the sound of the first preamp section. It might actually take a little bit of the gain down when we turn the diode rectification up. It just depends on what that range of voltage is, but it might stiffen it up a little bit more and make it sound a little more just alive and natural and loud. And it's hard to say, it's hard to explain. It's like a stiffness, right? It's like a tight, overdriven, feels like more modern amp, whereas a more vintage amp, you'd have the tube rectification. It's a little bit more slower. It's a little slower to do its job. When you're playing, it feels like the attack isn't quite as aggressive. It's a smoother feel. Sounds great for clean sounds and all that, but you know, these guys are going to be good for high gain. At least that's the theory here. Let's throw them in. So I just need to figure out where am I going to put these guys, because they really should be put on the red wires, and then I could extend the red wires to these pins, or I could just put them right on the pins, right? But then I'm going to need to take the conjunction of these guys like this. I'm going to need to take the where they connect together after the set of 4 and run that to the switch, and then the B plus, which is here, this red wire, which is going to this filter cap, and the output transformer primary, which in this case it's a blue wire. Most cases, most amps, that's going to be a red wire. That's not the case in this Kalamazoo's output transformer. It's a blue wire. So usually I'm used to seeing a red wire for that. They do have a red wire, but that's different. That's going to the power tube. In this case, on this primary, it's the 6x4 tube. So these two things need to go to the middle of the switch for this, because we're going to say this is what we're supplying the amp. Either it's coming from the tube, which is coming from this pin right here, right, where they're connected now. That's going to be the tube rectification, or the intersection of these diodes. So I can put the diodes on here and just kind of make like a bridge, but then I'm going to have a wire coming off of it going down here. That's why I was thinking maybe it'd be cleaner if I had, like, unfortunately I don't have this, but if I had like a set of open terminal strips, I could run the red wires from the transformer to these terminal strips. The only problem with that is I broke off this one to make these wires fit here, and this middle one is going to ground, and we can't have that going to ground. Otherwise I could use these two terminals right here, run the red wires to here, run the wires off to the tube, and have these intersect and go straight down. That'd have been a little bit cleaner, but I don't have that option here. I don't have enough terminals, and if I add another terminal strip here, it's just, I'd probably have to add another 2 terminal strips in order to put these in there in that kind of configuration. And there's just not a lot of room here, so I think I'm just going to go ahead and do it off of the pins, and just we'll figure something out to make it stable. But I looked over here, there's just nothing else. This is an open one over here, but it's grounded. This one's grounded, this is ground, that's ground, this one's open, but I don't see any reason to take something all the way back over here and then bring it back this way. So if it just goes from here to there, it's going to be a lot shorter. Why take it there? And that's only one terminal, not, I would need 2. One for each red wire to go to, if I was going to do this in a more structured way. You see what I'm saying? Hopefully that makes sense. So 1 second. I just wanted to show you what this looks like on a schematic, diode rectification and tube. This is a really good one because it's very simple. It's a D-Lab Electronics. If you ever watched Terry from D-Lab on his YouTube channel, Terry's been on YouTube for, gosh, at least 15 years, I'd say, And I learned a lot from his videos over the years, but this is one of his designs. It's a simple little 3-watt amp that's got a 6SJ7 preamp tube, a 6F6 power tube, and a 6X5 rectifier. This one is a 6X4, right? So it's a little bit different. This is an octal tube, which has 8 pins, and this one has 7 pins, right? But what Terry designed in here is he's showing, here's your power transformer, right? It has a center tap, which is right here, this red and yellow. It has 2 red primary sort of high voltage leads that come out and go to pins 3 and 5 of a 6X5 tube. In this case, it's going to pins 1 and 2, 3, 4, 5, 6. 1 and 6, right? 2 red wires, 1 and 6. There's 7 pins total, right? So they're going there. But in the middle here, there's a part where it breaks off, and it's showing the 2 1N4007 diodes that are coming one off of each lead. Essentially, this connection right here is the same as connecting that diode to this pin. It's all one wire, right? That little jump means it's not connected to this wire, but it jumps over that wire. But so then the 2 diodes connect together to an intersection, and that intersection goes down to one side of your switch. The other side of the switch is wired to the tube. Right now, that's hardwired with this primary of this output transformer, which is the blue lead, and our B+, which is our filtration over here, right? That's where that's going. So we need to move those wires to the switch, right? And then the center of the switch in this case is going to go to the intersection of these two. Sorry, we're going to move these two to the middle of the switch, connect this lug, which is to the tube for tube rectification, and connect the intersection of those diodes, which are going to connect to these 2 pins, to the other side of the switch. I know that's a lot. Let's do it so you can actually see, but I just wanted to show you on a diagram what that looks like, because this is a very simple and easy way to do it. The only difference with this and mine is that I'm going to add an extra diode at the end of these 2. In case one fails, it's just a backup. You don't need 2 to do the job, but you only need, meaning you don't need 4 to do the job. But I'm going to do it that way because I can, right? And I'm showing you that this is a method that you can use as a backup, just in case one fails. They're cheap enough and easy enough to do this. Why not do it? That's what I say. All right, so if we go that route and we're not going to add any extra terminal strips, then what I'm going to do here is, let's see, I'm going to go ahead and trim off about 1/4 of an inch of the first one. Oh, and the direction of these do matter. You can see that on a diagram, you'll see a little triangle pointing to a line. That line is where you see the white on the diode is black and it has a little gray or whitish end. That's where that little vertical line is, right? That's the one side of that diode where you see the line. So you don't want it to be this way. This would be backwards. Oops, sorry. Oh, I just dropped it. You don't want it to be like this, where the white or silver line is going that direction. You want it to be going this direction towards the switch, okay? So hopefully that makes sense. So here's the gray line on this side. And I'm going to go ahead and just make a little curve in here. Put this in. Now, remember, the pin that I'm putting this on is pin number 1, 2, 3, 4, 5, 6. And that's where the red, one of the red leads from the power transformer are connected to. Once this is wired up, I'll be able to show you what, where the wires are. I'm going to run a wire from either the tube to do the rectification or the intersection of these diodes to do the rectification are going to go to the switch. And then I think it'll make more sense if you're having trouble visualizing it. So just stick in there for a second. All right, so I'm just going to put one straight up like that for right now, just to get it in place. I just need to, I got to move my microphone just slightly so I can get this soldering gun in here without burning up anything. Come on. Okay, that should do that one. Okay, once it's soldered, it kind of gets stiff. It gets stuck in place. All right, so I'm going to cut off about the same amount, about 1/4 of an inch on that one. Don't have to do that, but since I'm putting 2 of these in there, I just wanted to shorten the distance a little bit. And then this one is going to go on this one where the other red lead, right? And just remember the silver stripe is at the top. The black part of the diode is where the closest to the wires, where closest to the pin socket. Sorry. Just have to heat up this. It keeps moving on me. Hold on a second. I have to use a pair of pliers that have some grip to them, or it keeps moving. Come on. There we go. Get in there. There we go. Okay. I do want to put a little extra solder on that. And sometimes what you can do is just grab a tool before I loosen that solder again, just to like have something for it to rest on so that it doesn't move like that. There we go. Now let that solidify. Probably should have soldered the 2 diodes together to each other first. What I mean by that is the backups. So those are going to be the 2 backups, or these 2, doesn't matter which. So in that case, I'm going to go ahead and leave about a 1/2 inch or so on both of these. Do the little J-hook thingy. Just bend that over. Bend that over. And same direction. So I know you can't probably see this, but there's 2 diodes, 1 on each where the red leads are from the power transformer. The silver stripe is furthest upward, near this side. And I'm going to do these the same direction. And I'm just going to attach these to those in the same direction, meaning the silver stripe is up. Okay? So I'm going to cut this end off, which is the black end. Not the end with the silver stripe, right? And then just put this on here. It's probably a little too much. I probably could have cut a little extra off of that one. But I'm just trying to kind of chain link them together, right? And by me pressing them, hopefully you can see that they're like linked to each other. Right? Solder them. Whoops. Oh, sorry, my soldering gun stand here is like falling apart, but it's extremely hot. Okay. Okay, let's cut off this end 2. This is the black end, not the silver end. Again, just make a little hook. So just going like this. You can see that. Hook that on here. Whoops. Let me go ahead and crimp this just a little bit more. All right, so they're both facing the same direction, that with the silver stripe up. So if one of these fails on one side, there's another one there that can do the same job. Once it's rectified, the other one it just passes through the other one, right? So it's not going to do double the work. Once it's changed it to DC, it's gonna stay DC, right? So I'm just putting an extra set on there. Whoops. I'm just trying to crimp this hard so that it'll stay just enough that I can solder that. And then we're going to connect them together with a wire. Alright. Little solder there at the intersection, and this is what we have so far. So I'm going to bring this close so you can see. See how that looks? We have the two pins where the red wires are connected. We have the diodes going up like this, and now we're going to bring them together to intersect them. Hopefully there we go. Now you can see. So the silver ends are all up. That's the direction we want. Now I'm going to go ahead and just twist these together. And I don't need to go nuts with this, but I'm just twisting it enough so that I can solder that. I'm just going to put a dab of solder on it for now because I do need to connect a wire to it, but just put a dab on it so they don't come loose. And I can also trim it. So now they come to a single point, right? So that's all 4 diodes all coming up, connecting to a single point. That right there is going to be, we're guesstimating close to 300 volts of DC. And we want to connect that to this blue wire and this red wire, but we're going to do that through the switch, right? Otherwise, the blue wire and the red wire are going to be connected to this pin that they're connected to now to use the tube rectification. So this is where the tube is being rectified and changing to DC. These two are AC. It's going through the tube components to output it to DC, and that's what they're connected to now. So we're going to disconnect these, take them to the middle of the switch. This intersection is going to go to one side for diode rectifier, and this pin here is going to go to the other side of the switch for tube rectification. Make sense? Hopefully it's starting to come together. The only issue I have here is like stability, right? Since I didn't use any terminal strips or anything, I mean, this is pretty stable here. But I think what I'm going to do is just sort of bend this over a little bit and connect a wire. I have an idea for this. So I am going to use red because it is going to be high voltage. I have an idea for this to maybe stabilize this a little bit. I'm going to make this longer than I probably need just to be sure I have enough. Okay. I need to connect this to that intersection of diodes. So let me just take that intersection and J-hook that and clamp this on. Oh shoot, before I clamp that on, what I was thinking was if I push this through, actually maybe even like if I push this through this bundle of wires here, I feel like I'm going to get a little more stability in it not pulling on, nothing pulling on those diodes, because since they're just sort of floating there up above the tube socket, see how it's hard for me to push this wire through that bundle of wires? That's what I want. I want something to be holding this wire in place. So, see what I'm doing here? It's going down through this bundle of wires, which is all bunched up together, especially because I have these zip ties on. And that way, even if I pull on this, I'd have to pull on this whole bundle of wires, so it's not coming loose. See, it's barely moving. You know, I'm tugging it pretty hard. So that'll just give it more stability than me just running a wire here straight over to there. This stuff's important because you don't want stuff like this moving a lot. You don't want to pull it off, pull it loose. You know, it's unlikely that this would even move much at all and cause a problem, but the more stable stuff is, I'm telling you, the longer and more reliable it's going to stay. Okay, that's connected, soldered, and I'm just going to trim off this little excess piece. There we go. So that's our little diode bridge. Looks pretty cool. And again, this is now, I just hope I have enough wire now. I need to fit this down in here. We're starting to run low on space for this hole here. I'm hoping we got enough. And did I get enough to go make it to the middle of that switch? I think I have just enough. Let me just look. Oh gosh, yeah, just enough. Let me go ahead and just solder that now, just to make sure before I put the other wires on. We're almost done this mod, or this enhancement. I don't want to call it a mod. I'm calling it an enhancement because we can always undo this, and we can also set it to play as 100% stock so that we're not messing up the original circuit. All switches down, everything is off. There's not one enhancement that is in circuit with, or at least that's how we're trying to wire this thing. Hopefully I did it correctly. Alright, so that's just enough red wire there to make it to the middle of the switch. And again, this is an on switch. That means something has to be connected to this middle lug at all times. It's either going to be the one lug on the top or the one lug on the bottom. That's it. It can never be off. So because we need to have, in order for the amplifier to work, we need to have this rectification, this DC voltage, B plus voltage, right? So that's the middle of the lug. So let's take it from the switch. So from the middle of the lug, it comes out. Ow, comes out on top here. Oh wait, I did that wrong. I'm so stupid. Sorry, I'm rushing. It's not supposed to go to the middle. The middle is the output transformer. Duh. This needs to go to one side. So let's take this out. Okay, so see how easy that was to take out? Like I said, if I had wrapped this around and squeezed it and all that, I would have had to apply a lot more heat for a lot longer, and I could have messed up this switch, but we're still good. Okay, we need to go to, when it's in diode rectification, the switch would be up. That means this one and this one will be connected, so it actually needs to go all the way to this one, which of course is the furthest lug that we have to go to, but I think we've got just enough wire to do it. Come on, get in there. Hold on. There we go. It's in. Alright, sorry about that. That was my mistake. Hopefully you caught that before I did, and if you did, then you'd be like, wait a minute, I thought you said that was diode was supposed to be one side of the switch. It's not supposed to go to the middle. I'm just, my brain's not moving as fast as my hands. Alright. It's been a long day. Not of amp stuff, but of other stuff. Alright, so that's the intersection of the diodes. Cool, we got that covered. So now we have diode rectification covered. What do we need to do next? Well, we need to disconnect. We need to disconnect the primary of the output transformer, which is the blue wire, from this pin, so that it's not always going to use tube rectification anymore. The problem is, come on, get out of there. The problem is that, did they just wrap this thing around 1,000 times? This is what I hate. I don't want to ruin that tube socket. If I have to replace that tube socket because I'm pulling on wires that are wrapped around there tons of times, it's going to be so frustrating. I may just need to clip it if I can't get it out off of there. I'm gonna have to snip it. It's wrapped around like twice. I can see the can see the leads. That sucks. Alright, hang on. Where's my... Sorry, it's probably right in front of my face. Oh, here it is. I'm going to need to snip this. I'm not going to risk trying breaking this tube socket holder here for this. Alright, so this blue wire here is coming up from the output transformer. That needs to go down to the switch now. And what's cool about that is that's very easy to do because we could just pull it out of this hole and connect it directly to the switch below itself. Alright. And the other thing we need to connect there is the red wire from the B+, which is this. So I'm actually going to have to replace this wire now. When I ran this wire, I didn't know I was going to make this mod, so, but yeah, I'm going to have to replace this because this is not long enough, and I don't want to connect two wires together and bridge them, and not when this is a new feature that I'm adding. So yeah, the cool thing about this pushback wire is I can pull it back to expose the metal and then heat up this is going through the bottom hole lug. I should be able to just pull it right out with a pair of pliers so I don't burn myself. There we go. Okay, see, I just burned the cloth slightly on these green wires now. Not enough to expose the wire, but yeah, I mean, that's what happens when this stuff gets in here so tight. Got to be really careful. Okay, no damage done though, just a little surface heat. So I need to run another red wire from the B+. Where's red? Here it is. Because there's two things essentially that have to get, this all has to get connected to, is the B+ here, which I gotta make sure I got plenty of wire here. And this, which is the output transformer lead. Alright, so reconnect, no big deal, this is easy. Reconnect this, a new wire here for the B+. Try not to burn anything this time. Okay, just put a little extra solder there to make sure it's on good. Okay, that should do it. Just make sure nothing's touching the chassis. Is that good? I think so. Alright, that goes down. I think we're going to need to just have room for one more wire after this one. Hopefully we got enough. Alright, that one fits. I don't know if you guys are like me, but going like, how many more wires can you fit in there? Well, I only got one more to go after this one. I'm going to leave this one, I'm not going to solder this one just yet. I'm going to do the tube one next. So that one I'm going to do a different color. I'm going to do it orange. Well, no, I'm going to do it blue because I used blue on one of the other wires here for the original component. So this is going to go to the original component, which is the tube rectifier, right? So it's going to be tube rectification is original blue. Just trying to have a nice little color scheme so that if we're looking at the back of the panel, we can sort of tell where things are going. based on their color code. All right, so I'm just gonna wrap this through here. Wait, no, I think I'll do it like this. I'm just gonna do path of least resistance, but I think now I'm just gonna do it around the corner here, like this. All right, so the blue wire is going to be the tube rectification, which is going to pin 7. 1, 2, 3, 4, 5, 6, 7. Yep. And if you're curious, those pin numbers are always clockwise when you're looking down at the socket like this. Where you see the little gap here, you always take the one clockwise as number 1. See there's a little gap between these two pins. So start there and go clockwise. 1, 2, 3, 4, 5, 6, 7. Over here, a 9-pin socket would be little gap. Clockwise would be 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there's the blue wire. It's going through. That's going to be for tube rectification. I'm going to leave those little strands that were in there that I couldn't get off because I feel like it's not worth the risk of me breaking that tab trying to force those off. It's fine. It's not a mess or anything like that, but it could turn into a mess if I start yanking it more. All right, last wire. Let's see if we... Oh, look. It fits fine. Nothing to force. Everything fits perfect. Perfect. All right. All right, let's flip this sucker over. So we got the blue wire connected to the pin 7 for the tube rectifier. We've got the red wire connected to the diodes for diode rectification. We've disconnected this, and we have another red wire for our B+ filtering. Those were all just going to the 6x4 tube socket before, but instead so we have 3 wires here we need to connect. So we have the blue. Hold on. This blue from, I was gonna shorten this, but no, I'm not going to shorten it because I am gonna cut just the tip of it off though and re-strip it. I'm not gonna shorten it, that way if somebody wanted to reverse what I've done here, they have enough wire here to work with to put it back to where it was. But I do want to re-strip it to have a clean piece of wire here to work with. So we need to do this, and the B+ voltage needs to go to the middle of the switch because that's where it was connected on the tube socket before all this me changing anything, right? Does that make sense? Hopefully that does. So that means 2 things need to go to the socket. Now here's the problem. We're not going to be able to fit 2 things in this little mini switch hole. There's just not enough room. I mean, it's barely enough room for 1 thing to go in. I don't even know if this wire will go in there because it's kind of thick. Yeah, I don't think I can even get this one in. So I know I can get this one in, this red one, which is, remember, the red one here that's not already connected. The diode we already connected this one. This is coming to our B+ here. And that's, remember, it was B+ connected to the pin socket and the blue wire from the output transformer. Both of them were on the same pin, right? That's the 2 that we want to connect to the middle of the switch now. So I'm going to go ahead and do this. I'm going to go ahead and connect the red to the middle lug because I know it'll fit through that hole. And I'm gonna make sure there's enough excess to connect that blue wire to it, because I just can't push them both, literally push them both through that lug. That just will not physically fit. But that's okay, we got a workaround. We'll do a workaround here, and it'll still be nice and secure. I'm not worried about that. As long as I can get, I'm trying to get this in there without bending it too much. Oh, you know what? We had some solder on there, and that's preventing it from going through there. Alright, so maybe the blue wire would have gone through there if I had... Trying to be very careful not to put too much. Come on. Oh, see? The plastic started to melt already. God darn it. It's too much heat. I was doing it too long. Alright, it seemed to harden up, so maybe I'll be okay. Son of a gun. Alright, well, here's what I'm going to do for now. I'm going to leave it for now, and I'm going to bend this outward and connect the blue wire to it. Which means I need to strip just a little bit excess. I might have to change that switch. It seems okay now. It still functions, and this seems stable now that it's cooled down. Or is it? No, it feels loose. Shit. A little bit loose. Alright, I'm just going to try it for now, but I have a feeling I'll have to come back to this and change it. Son of a gun. Alright. I want to... Wait, before I do that, let's just connect this blue wire to the bottom lug. Make sure I'm not going to have any issues with that one. See, I mean, I was talking about this the whole time. And, you know, if you happen to skip ahead, I was talking about how too much heat on these mini switches, I mean, literally just an extra second or two past the 2 or 3 seconds you need to get something on there is going to melt the plastic that the pin is going into, the lug that you're soldering to, and it can ruin the mechanics of that switch. Like, I've had it before where it just won't switch anymore. Like, it'll be stuck there, and that's because the internals of it got melted together and something broke. I have a feeling this is probably still okay at the moment, but I think it's enough. It might be okay enough for right now for me to just test this, but I think I might have to swap this out for another one. It's because I screwed up and I had to unsolder something, and now that I've unsoldered and resoldered a couple times, just the integrity of this is just, it just doesn't look good. So don't do what I'm doing and just move forward and replace it while you're down here, but for right now I'm just moving forward because I really want to just get to the testing phase, and then I'm probably going to switch this out. And this is important because this is your rectification, but I am going to check continuity, and if the continuity it doesn't look good, then I'll definitely have to replace it now. Alright, so the blue transformer wire, output transformer, that is this guy right here coming from the output transformer, the red going to our B plus filtering, that's connected to the middle lug. This end of the lug, which is when the switch is up, is the diode mode. This red wire is connected to the diodes. When the switch is down, in a down position, then it's going to the blue wire that I ran myself, which is going to the 6x4 tube over here. So that's saying get your rectification from the tube or get your rectification here from the diodes. See what I mean? Both red leads are going to either the diodes and or the tube pins to get rectification. It's just the output of that rectification is either through these diodes or through the tube itself. Okay? So yeah, before I commit to any of this, I just need to check this continuity at least. I have a feeling the switch is going to be fine for testing, but for the long term, I'm going to need to swap it out with something else with another one. So for right now, if the switch is down, we want tube rectification. That means the middle lug, which is here, to the blue wire, which is this lug down here. Okay, we have continuity, so that's good. Okay, switch it up to rectifier. We should not have continuity to tube. Uh-oh, we do. Son of a bitch. We have continuity to both. That means this switch is screwed up. Alright, so I will have to change it. Wait. That's tube. Yeah, it's not right. Something's not right. Or is that just because it's going through the diodes? Screw it. I need to change it out. Alright, let me do that off camera. And maybe when I get back to the next part, we can I'll have this ready to go and we can fire it up and we can start bringing it up on a variac. I am going to bring it up on a variac slowly, maybe even with the light bulb limiter and everything, just to make sure there's no mega shorts, because this is a lot of work, and especially doing stuff with the rectifier. That's your main power, right? It's your main power source. It's part of that whole thing. I want to make sure I didn't really get this screwed up, and the integrity of this, I should not move forward with this. It just doesn't seem right. This is loose. This middle lug is loose. It's possible that no matter whether I have it switched up or down, it's going to use both tube and diode rectifier, which I don't think is going to blow anything up. But it doesn't let us switch between the two with it being broken like this. And like I said, it was just a little tiny bit of extra heat that I shouldn't have applied, just an extra second or two, and that plastic started to melt. Let me show you this closer so you can see what I'm talking about, in case you can't see this. I'm sorry I don't have a close-up view. It's just hard for me to work with another view, but take a look at this. All right, so remember the middle lug, I accidentally attached this red wire to it, and I realized, oh, no, that needs to go to one side. So I unsoldered it from the middle lug here. Then when I went to go resolder something else to it, it has been soldered and unsoldered too many times, and look, see how that moves now? It's loose. It's because it got too hot and it melted the plastic that it's going into, and now the mechanics of this switch are not right. This lug's fine, this lug's fine, but the middle switches, which is the one that's going to kind of control switching from this one to this one and so on, that's screwed up. So we have both of these wires connected together. This one goes out to the tube rectifier pin, and this one goes to the diodes. But yeah, this is, see how that moves like that? I can't really pull it out of there, but it does rock back and forth, and I have a feeling it's maybe because of the continuity showing me that it looks like it's connected, whether both of these are connected to the middle lug, whether it's on or off, or up or down, I mean. That I think that means that this is screwed up inside. So, yep, it happens. That's why I need to get extra parts when you're doing this stuff. So I'm going to unsolder this, throw this switch away. I can save all the hardware though. Yeah, I can save the little washer nuts and all that kind of stuff. Definitely save all that stuff, but throw the switch away. Don't put it in a pile where you can accidentally pick it up again and use it in something. It's just going to be bad. And luckily, these things are pretty cheap. If you buy them in bulk or buy them on Amazon, I just got a whole pack of 10 or something, or 20 for, you know, pennies, compared to buying them one at a time at a amp parts supplier, which would cost you a few dollars a piece, probably, at least. But yeah, you can spend about the same amount of money and get a pack of 10 instead of buying 2 switches, you know. So do that if you can. But yeah, I'll rewire this up, get it. It's gonna be the same wiring, just a new switch, and we'll set it up to test with a variac. So hang in there, we're almost done. At least ready to see all these enhancements in action. I'm excited. I can't wait to hear what this is going to sound like, because we haven't tried with all these things turned on at once, because I still haven't tried out the rectifier mod on this particular amp. I have a feeling though, each switch you hit, it's going to get more intense and hotter sounding. Not hotter, but tighter. It's like okay, boost it with some gain boost, voice it so that the gain sounds good, then hit this one on for volume stability, that's the bias, and then now let's switch it to diode rectifier, and bam, that's our hot rod setting. All these switches up. And if I want to change the voicing down to a bassier setting with all these other settings, I can do that, because each switch is individual, right? So I think it's a cool little thing. I think it's going to work really well. Can't wait to try it. Okay, my friends, I skipped ahead just a little bit here and built the panel, finished the panel. Basically, from what you saw, I did... hold on a second. Sorry if there's a little bit of an echo. I've got my headphones set up ready to go here for a demo, and I can hear my voice through them. Yeah, so this panel is now fully done, and I did replace that rectifier switch. Remember when I was soldering it on the last section, unless you skipped around, I applied too much heat and messed that one up, so I did replace that. I just took the wires off of the old one, put a new one on, and we're good to go. And I've also hooked this up to a variac. I just figured I would save you the time. I've got other videos, this Gibson Skylark restoration, where I show in detail how to hook the variac up to the amp up to that, so that we can safely bring up power and test everything. I didn't want to get into all that. This video is already getting too long. So I've already tested and make sure everything works, and everything was perfect the first time. I didn't have to change or adjust anything. And I even labeled it, so as you can see. So I didn't want to show that because I do have other videos of the way I do these kinds of labels on these sort of panels and stuff. This is just made from a vinyl cutter. You know, the silver vinyl that I put over the piece of aluminum that I made for the panel. I just put black vinyl lettering over that. So I have one of those vinyl cutter machines, like the Cricut machine, although mine's not Cricut brand. It's what is it? Silhouette? Cameo? I don't remember what the name of the brand is, either Cameo or Silhouette. But anyway, you put these sheets of vinyl in that have a sticky backing, and you design it in a software, and then it cuts out the letters, and then you have to transfer them using transfer tape and place them on, basically. So that's what I did here. It gets a little tricky here with these really skinny, tiny little letters here. I mean, they don't look that small, but when it gets any smaller than that, it's almost impossible to work with this stuff, because you have to weed out all the little O's and R's and all kinds of little things here. The A's have a little piece in the middle. You have to take all those out, right? It'll cut them, but then, you have to take out the centers, which gets really tricky, and usually you wind up pulling up the letters or messing it up. So anyway, long story, this one wasn't too bad. I was able to get it all done, so now I have everything labeled. So let's go ahead and listen to this thing and see what we got. And I've already done this, and man, I'm telling you, this is truly now a hot-rodded amp. Remember, all switches in the down position are stock settings, so nothing is different from what Gibson did when they designed this Kalamazoo 2. There's literally nothing different. The only thing is, instead of hardwiring the speaker, I have this run into my computer right now, but now we can use these speaker outputs. Both of them will work to send the signal out to either this speaker, which I still need to solder on a little plug for that, but that's essentially what I'm going to be able to do, is just plug the speaker in and out with a plug like this. So this is run into my computer, into the 2 Notes Captor X, just same way I've been demoing this amp from the beginning, so that you can hear it. I can directly put the audio onto this video for you to hear what it sounds like. There is a tiny bit of room reverb that's on, but that just kind of expands it a little bit, makes it sound good. So let's listen. I'm gonna put my headphones on and we'll hear what it sounds like. Alright, let's see. That's about half volume. Amp it full volume, stock sound. Gain boost. Voicing. Here's the loose versus tight mode. And then rectifier instead of diode. Notice that I don't have this fully screwed in yet. It's attached to the chassis, but I'm gonna screw this in so that this doesn't wiggle like this to this back panel. So it's a little loose right now, but it's gonna be secured. Let's try this again. Stock. Turn the master volume just a little bit. I think that's about half. Yeah, volume's about half. Yeah, man. Turned it into a little hot rod. I mean, some of these settings, you know, there's not like a mega change, right? It's more like a fine tuning sort of a thing. There is a mega change, I think, on at least on these first two, the gain boost and the voicing, that other cap that we were replacing to cut some of that real flubby bottom end and tighten it up. It definitely sounds good with the distorted pushed sound. And these guys are very subtle changes in the sound, but the feel is different. Like it feels tighter. Like it feels like everything's just charged with more, which it is really. Remember, I was going to check the voltage. I think it was around like 285 or something like that for the B plus on the tube rectification. When I hook a meter up to it, it gets up to like I think like 315 or 320, something like that. So it jumps even more voltage than I thought it was going to. So yeah, it just tightens up everything, gives everything a little more power, and then adding this bias cap, this cap, the 100 UF cap around that bias resistor really keeps things from dropping out, keeps that volume from dropping out so quickly when you're hitting a chord really fast. It's like the volume's there. It almost sounds like a gain boost. And in theory, it is a little bit of a gain boost because you're pushing more signal through the power tube, a slight bit more signal, at least more consistently through the power tube than it was able to handle before. So that cap is kind of charging that up too, to make sure that your signal is staying very consistent. So yeah, very cool. I'm really happy with the way this turned out. I definitely like this a lot. I've got a little more work to do. I'm going to add a cord to the speaker so that can be just plugged in. I'm going to make sure I mount this properly because it's still a little bit loose here. I need to cover the back completely because if I were to reach my fingers back there and touch anywhere near this switch, I could get shocked with 300 volts potentially. So these other ones are safe. It does sound very quiet to me, so I don't think I need to use any insulated or shielded wire. The only one I was going to do that on, I think, was this voicing one because I think that one was going to be the most sensitive. But honestly, the way we designed it, with most of these things being grounds, just certain components connecting their end to ground to put them in the circuit or take them out, doesn't seem to add any noise to anything. And I think the way we wired it up top makes a difference too, because I was very careful about where some of those wires were crossing over things and, you know, where there could be potential noise. So the way it's wired, I think, has a lot to do with that too. So I don't think I'll need to even add or change or do any what do you call it, any shielded wire to this. Yeah. What else? Cleaning the cabinet, obviously, still have to do that. Get all this glue off. There's a little bit of glue here and there that from this panel that I made. And yeah, just dusting it out and cleaning it. So I might do that on a time lapse, so you don't have to see every bit of me doing all that, but you can just kind of see the process. And I have other videos where I explain exactly how I clean old Tolex and stuff like that. Mostly just in this case, it's not very dirty, so I'll dust everything with a vacuum. I'll use a scrub brush, something that I can get in the grooves of the Tolex and just use some soap and water, like Dawn dish soap and warm water is usually plenty enough. You wipe that off, rinse that off, and then if that gets most of the dirt off, then you just apply a Tolex, what do you call it, cleaner. And I'm going to probably use something similar, if not the same thing, for cleaning the faceplate and stuff. This Music Nomad, I really like this stuff a lot, for cleaning Tolex. And again, it on most faceplates, maybe not all of them depending on how the labels are done, but on most faceplates this stuff will brighten up the faceplate too and clean it and brighten it up and make it look really polished and nice, almost like a guitar polish but for your amp. And like I said, this is going to shine up this Tolex really nice, but I do want to clean all the dirt off of it first, and the best way to do that is going to be a nice soft bristle brush that can really get in the grooves, and I'll get all that dust and dirt over 60 years off of this thing. And also need to take the speaker out because I'm going to carefully clean that as well. And I haven't even inspected it, but it sounds good, so I don't think there's anything wrong with that. And there is a paper version of the schematic that's stapled to the inside of the cabinet on this side. So I want to cover that up and make sure that does not get wet at all, because that is part of the originality of this amp, and I do want to preserve it. I really like when they did that, putting in the actual schematic. I mean, it's small and it is a little tough to see, but as a quick reference guide for quick servicing, it is cool that they did that. So I don't want that to get damaged or wet. I may even see if I can just take it out of there and maybe reinstall it when I'm done. If not, I'll just cover it with some plastic and tape so that I can clean around it and not worry about getting water and soap and stuff on it. So yeah, this is coming along really well. We'll be finishing this up soon, but I might do a final demo at the end and also maybe show you some voltages and things like that. Actually, I can probably do that now just to show you what that B+ voltage is. Let's just see if we can hook that up real quick without me shocking myself. It is a little tough now because now I need to get a ground. Okay, there's nothing immediately right here that, well, no, that's true. That could shock me. Let's do this. There's a ground lug here. Let's have to be very careful. All right, hold on a sec. I'm going to move you back a little. Okay, see the meter here? It's on DC volts. All right. If I put this on the B+, which is the first filter cap, right? That's, let me just make sure I get just that and not the ground. Is that good? Yeah. So what do you see? 284 down there? Do you see that? Sorry, there's a bit of a glare. I'll see if I can. Oh, man, hold on. Sorry, I'm trying to get this so you can see it. Hopefully you can see that. It's 284. That's with the tube rectifier. If I switch this to diode, 315. See that jump? So that's the diodes doing the rectification. Typically it's always going to be higher with the diodes because the tube is it's a different kind of a component. It's slower to do the rectification and doesn't produce as much depending on the actual model of the tube itself. So this 6X4 is just kind of a little guy for little circuits, you know, nothing major. It couldn't power like a really big circuit or anything like that. But yeah, big difference there, huh? So that's just giving this amp that much more power, like 30 more volts, you know. So it's cool. Very, very cool. I'm gonna be extremely careful here with my hands. All right. So yeah, cool to see that jump there, and that's just the B+, right? So that is going to essentially increase other points in the amp too that have voltage going to them, but that's what the output transformer primary now, because that's where that's connected to. The output transformer primary is going to have that jump in 30 volts, and it's not enough that it's going to harm it or anything like that. It's rated for more than that. So, but yeah, it's cool that we can just add these little switches and give it kind of a new sort of life as far as being able to use it as a semi-high gain amp. I wouldn't call it an ultra high gain amp. I mean, it's literally just got one preamp tube with 2 gain stages, but with the changes we made here, when you're switching them up to change them, it really does add a nice high gain feel, like at least a hair metal-ish kind of a style. I could do some pretty cool stuff with it, and it makes a really good recording amp too. If I actually picked some really good virtual speakers, or even mic this cab up with a real microphone, we could probably record a really decent like rock album, or even like metal, maybe not like super death metal or anything like that, but you know, you could really do some cool stuff. Matter of fact, before I shut this off, let me just try a guitar with hot pickups and see what that sounds like. It might be really crazy, I don't know. I mean, I don't think, obviously, guitars like that, like metal guitars with not passive pickups, but actually active battery-powered pickups, are going to push a lot more signal. But let's just hear what one sounds like. Alright, I've got this ESP guitar with the EMG pickups that are powered by a 9 volt battery. I'm just curious. I haven't tried an active pickup guitar in this thing yet, but now that we have these settings, I'm wondering if it will handle it. It might be a little too much for this amp, but let's see. Okay, crank the volume. A little overdone, but sorry, it's a little out of tune, but yeah, I mean, it's not terrible. It probably would sound better if I connected some kind of like a tube screamer to the front of the amp and used the gain boost and the voicing. It probably would thin it out just enough with that kind of a pedal and give it a little extra drive to actually make it sound pretty metal. So lots of cool experimenting we could do with it now, but having these different modes and stuff can really fine-tune that overdriven sound. And again, I'm just showing you the overdriven sound because that was kind of the purpose of this, making this a hot rodded amp. All of the features that the amp originally had to play clean are still there, right? We can still play this thing exactly stock and have it sound exactly the same as it did. Sorry, I had to plug the other guitar back in, but yeah, like if I switch my pickups on this Fender Strat and tone it back to stock and not crank it all the way, where you can really hear the difference here on the tight and the loose. It's really making that volume come up. So even using it clean, right, with a clean setting and just having these three on, I feel like I can get a much like more powerful sounding clean sound, right? Even with no gain boost. Just turn the gain boost off. Then it just is stock with, you know, the volume turned down to like 3 or 4, which would be before the amp really starts to break up. Listen to that again. Just with these three, how much more powerful that clean sound sounds. Here, off. Sounds very thin. All right. Anyway, this is just so much fun to play now because I can really rock out on it, and it has a good sound. So just making those couple little changes. All right, on to the next phase.